ಸರ್ ಜಾಯಿನ್ ಆಗಿ, ನಮಸ್ಕಾರ, ಜಾಯಿನ್ ಆಗಿ ಬಂದಿದ್ದಾರೆ. ಅವರು ಡಾಕ್ಟರ್ ಇವರು ಬಂದಿದ್ದಾರೆ, ಯಾರು ಚಂಡೀಗಢ CSIR ಲ್ಯಾಬ್ ಸೀನಿಯರ್ ಸೈಂಟಿಸ್ಟ್ ಡಾಕ್ಟರ್ ನರೇಶ್ ಚಂದ್ ಜಾಯಿನ್ ಆಗಿ ಸರ್. ಓಕೆ ಓಕೆ
Okay, sir. We are going live now, sir.
Yeah, okay, sure.
The entire world is covered in darkness due to the COVID-19 pandemic. But this darkness is only temporary. Darkness is always defeated by the light. It is during these darkest moments we must focus to see the light. Let us together defeat this darkness with the help of knowledge. Our ancient sages say that there are two ways of spreading the light of knowledge: by being the candle or by being a mirror. We, at the Department of Electronics and Communication Engineering, Vidyavardhaka College of Engineering, Mysuru, feel proud to be the mirrors who are merely reflecting the light of knowledge from the resource persons. This 5-day faculty development program on recent advances in photonics technology is being organized by Department of ECE, VVCE, Mysuru, in association with IEEE Photonics Society, Prakash, Bharathi, India. Greetings from VVCE to all, and I hope all are doing well. I, Kavya AP, working as Assistant Professor in the Department of ECE, VVCE, Mysuru, take great pleasure in welcoming you all to the 5-day faculty development program on recent advances in photonics technology. Let us begin this event by seeking the blessings of God through this prayer. Om Adityaya Vidmaye Sahasra Kiranaya Dhimayi Tanno Surya Prachodayat, which means we seek the blessings of the Sun God, the one with thousands of rays to illuminate our intellect. We are very glad to inform that around 500 participants have registered for this FTP from different states and also from different countries. So we are streaming this through YouTube. So now I take this opportunity to formally welcome the gathering. I extend a warm welcome to our today's chief guest and speaker, Dr. Naresh Chand, Life Fellow of IEEE, Associate Vice President, Chapter Relations of IEEE Photonics Society, Warren, New Jersey, USA. Welcome, sir.
Thank you.
I extend hearty welcome to Dr. Rajkumar, Senior Scientist, CSIR, Chandigarh. Welcome, sir. I also extend warm welcome to Dr. S.M. Prasad, Chairman, BOS, Technical Education, Government of India. Welcome, sir. Hearty welcome to Dr. P.C. Srikanth, Chair, IEEE Photonics Society, Prakash, Bharathi, India, who helped us find this team of wonderful resource persons for this FTP. Welcome, sir.
Thank you.
I extend a wholehearted welcome to Dr. Chandrasekhar M. Patil, Professor and Head, Department of ECE, VVCE. Welcome, sir.
Thank you. Thank you.
I also welcome my colleagues and fellow coordinators of this FTP, Mrs. Girijama DL and Mrs. Kavishri B, Assistant Professors, Department of ECE, VVCE, and most importantly, I welcome all the participants. May I now request Dr. P.C. Srikanth, Chair, IEEE Photonics Society, Prakash, Bharathi, India, and Chief Convener of this FTP to introduce the theme of this FTP.
So thank you.
I think people should turn off their microphones. There is echo is coming, so
Yeah.
I think we can turn off our microphone. Only the speaker should leave it on. I am also turning.
Yeah, I think all of you mute the microphone. Yeah, okay. Am I audible now? Hello, am I
Yes, sir.
audible?
You are audible. You are audible. Yes, sir.
Okay. So thank you, Professor Kavyashree, for welcoming everyone. Once again, I would like to thank the principal of this institute, Sada Shivagowda, HOD Chandrasekhar Patil, and our distinguished keynote speaker and chief guest today, Dr. Naresh Chand, Associate Vice President, IEEE Photonics Society Globe, and also Dr. Rajkumar, Senior Scientist from CSIR Lab, Chandigarh, Dr. S.N. Prasad from Government of Karnataka Board of Studies, Direct Technical Education. And this is a time to tell you about the very brief about the faculty development program that has been entrusted to me by the authorities of the college. So in this way, I think as Kavyashree told, we are moving from darkness to light. Definitely it is true, because in the days to come, instead of electronics and communication, it will be photonics and communication. Days are not far off, if I am true. It's a matter of time. So in this matter, we have done several workshops all over India, every nook and corner of India, like including IIT Guwahati, IIT Delhi, IIC Bangalore, IIT, many IITs, and then some places like Varanasi, then Janpur, then now Hisar, Dr. Rajkumar, along with Gurujambeshwar University, they are doing one more AICT approved this one. And all parts like southern part to northern part and eastern part to western part, we have conducted several this kind of faculty development programs and FDPs. I am glad that this Vidyavardhaka College of Engineering, they have come up with a proposal to conduct FDP like that. And incidentally, I am very happy that Dr. Naresh Chand has agreed to speak over a few things in the globe, how photonics is encroaching the whole world. In all fields now, photonics is encroaching like that. And also, we have got eminent speakers like Dr. Papan Reddy, who is a pioneer in the field of optical networks from Purdue University, USA. He has done a lot of good work in the area of optical networks, and he will be giving some hands-on sessions also. And coupled to that one, we have Dr. Gopal Krishna Hegde from Indian Institute of Science. He is a very expert in the area of fabrication. He is I think, Deputy Director from Nanotechnology Department, Nanoscience Department, ISA Bangalore. And also another speaker, Dr. Saidi Reddy, he will be speaking about fiber optic sensors. Of course, what they are telling this 5 days, whatever, 7th to 11th is a very short gap. We cannot cover the entire thing. At least we can deliver some good things so that they can imbibe their knowledge. So in that context, I would have already told that this is a very good turning for our photonics, because Vidyavardhaka will be a trendsetter, because Dr. Rajkumar, Dr. Naresh Chand, and Dr. S.M. Prasad, they wanted to give some good diploma course in photonics from Government of Karnataka. So we will be working towards it from today onwards. This will be a start from Vidyavardhaka College of Engineering. Okay. So with that one, finally, I would like to thank my dear student, Professor Girijamba. She had a very good publication under me, and she has got good project award, best project award in MTech. And now she is serving in the same college, that Vidyavardhaka College of Engineering, and also Kavyashree, and my dear fellow colleagues and contestants. So with this one, I think I would like to conclude my remarks. I think someone can take over in the next, this one, I think Giridamba or Kavyashree. Thank you. Thanks for giving me an opportunity to speak few words.
Thank you, sir. I now request our HOD, Dr. Chandrasekhar Patil, to address the gathering.
Okay, thank you, ma'am. Very good evening, one and all, and warm welcome to the resource person, Dr. Naresh Chand ji, and distinguished amenities, Dr. Rajkumar sir, and Dr. P.C. Srikanth, Dr. S.M. Prasad, and other resource persons, and all the participants across and outside India. So knowledge is a power. It controls access to opportunities and advancements. Firstly, I would like to congratulate all the faculties, and the faculty coordinator and their team of ECE, who has taken a lot of efforts to conduct this workshop, that is 5-day faculty development program and recent advances in photonics technology. Really, it's a great initiative, that in COVID situation. So I congratulate the faculty coordinator and our team. So photonics plays an important role, driving innovation in an increasing number of fields. Applications of photonics spreads across the several sectors, from optical data communication to imaging, lighting, display, healthcare, security, and also safety. And the main objective of this workshop is to enhance the knowledge of photonics and its technology. So finally, make use of resource person effectively, hoping that this workshop can successfully acquire the skills. So finally, I wish all the very best and this workshop, which is going to be successful and fruitful. Thank you.
Thank you, sir. I now request Mrs. Kavyashree to introduce our today's chief guest and speaker, Dr. Naresh Chand, Life Fellow of IEEE, Associate Vice President, Chapter Relations of IEEE Photonics Society, USA, to the gathering.
Thank you, ma'am. Good evening, everyone. It gives me an immense pleasure to introduce our today's chief guest and also the resource person of today's session, Dr. Naresh Chand. Presently, Dr. Naresh Chand represents IEEE Photonics Society in multiple voluntary capacities. Recently, he has got retired from the US and R&D Center of Huawei Technologies in New Jersey, where he was working on developing low-cost advanced technologies for ultra-broadband optical access networks since from the year 2011. Prior to this, Sir has worked for BAE Systems from the year 2003 to 2011 and at Ague Systems and AT&T Lucent Bell Laboratories from the year 1986 to 2003. And he has also worked in the Department of Electronics, Government of India from the year 1974 to 79, where he was involved with the licensing and development of electronic component. His areas of research are optical communication systems, fiber to the home, RF over fiber, non-hermetic lasers, reliable high-power pump lasers, VC cells, HPTs, HEMTS, and many more. He has several first and world records to his credits. He has authored more than 180 research papers and 15 patents had been issued to his credits. He did his master's in electronics in the year 1974 from BETS, Pilani. On a British Commonwealth scholarship, he did his Master of Engineering in 1980 and PhD in the year 1983 in electrical engineering from the University of Sheffield, UK. He also did 2 years postdoctoral research at the University of Illinois at Urbana. We are very fortunate to have you with us, sir. And thank you. Over to you, sir.
Thank you, ma'am. I now request our today's chief guest, Dr. Naresh Chand, to deliver the keynote address.
Thank you, Kavyashree. Thank you, Professor Patil. Thank you, Shrikantji. Thank you, Kavya, and the organizer, Dr. Giri Jamba, to invite me today in organizing this event. I'm really grateful to you. It is a pleasure, and it's my privilege to be with you because I'm a student. I'm not a teacher. I never taught anywhere, and you all are teachers. So I have a great respect for teachers. By the way, can you hear me and see my screen?
Yes, sir.
Yes.
Hello?
Yes.
Okay, good. So it is really my privilege to be talking to you. And this morning, I'll be sharing some of my thoughts. The reason I'm involved, is all my volunteer activities in India, because for last 8 years, I was working for Huawei Technology, which is the largest optical communication company in the world today. And is a controversial company. But whenever I used to go to China, which I used to go very often, I see how, hard they are working. They crush the problem. And so I felt always guilty that I'm working for a Chinese company and doing nothing for India. Whereas I was not allowed to work, to any other foreign country. So now last year, because President Trump, he actually stopped the operation of Huawei in the US. So they essentially shut down the facility, and I took the retirement. So I'm fully, devoted to India today. And I really grateful to Shrikantji. Shrikantji is a great champion. He has been working tirelessly in promoting photonics, bringing people together. And we formed a group called Prakash Bharathi. We have WhatsApp group for the senior people, as well as we have a scholar WhatsApp group for the research scholars. So today, I feel that when we say recent advances, today the technology or the knowledge itself has no value until we apply it for some, developing the products which could help the society. So I took the liberty of adding these recent advances and opportunities in photonics technology. Later on, when I give my presentation, I'll be talking more about the opportunities, what are the opportunities here. So I do not know what to say in this keynote talk, so I put some slides together for you. First of all, we should all be taking a pride in ourselves. The science and engineering is a noble profession. We are always addressing the world's challenges. We try to understand the world as it exists today and create a world that never existed before, right? Whatever we see today, it didn't exist 10 years ago. Nobody had the cell phone. 20 years ago, nobody could think about email or internet. And now today, everyone, even in the village who has no knowledge, can use the phone. We live a respectful, honest, and meaningful life. We belong to a community of intellectuals and exchange knowledge with them, like we are doing right now. Across the globe, we can bring the people. We are responsible for discoveries, invention, innovations. We serve the society through innovations for improving the quality of life, developing next generation of products and technologies, creating jobs and prosperity. People say if God created the world, and though engineers and scientists, they are perfecting it. So, but the problem is that these scientists and engineers, industry, they are facing the big challenges today because the technology is changing so fast. And we have the global competition. And everybody is trying to, take our bread. Like China has so many people, they all are dedicated. There are no issue of religion, no issue of politics, no issue of elections. So everybody is working, developing the products and tech. Engineers' half-life has reduced significantly. Earlier, you become an engineer and you retire which company you join. But today, the technology after a few years, it can become totally obsolete. It may not be needed at all. Actually, some engineering colleges are closing. And so there is no lifetime employment anywhere. So this is the big challenge today. And on the other hand, despite the abundance of potential workers, engineers, right, companies have trouble in finding the critical skill or top-performing talent. And to address this, they are setting up their own expansive in-house training program. Dr. Rajkumar is here. He could tell us CSR. Now they give their own PhD. They have their own university. The space department has their own PhDs. And you talk to any telecom company, they have their own institution. All the software companies, they all have their education branch. So obviously, we are not training the people or not giving them the right skill, and that's what needs to be addressed. I think the new policy, NEP, I think would address some of them. So to address this, the continuous learning, the faculty development program like this, are most essential. It's not a luxury. It is essential and extremely beneficial. So I congratulate all of you for participating in this event. Because you are like a seed, you would be taking the knowledge and sharing with your students and other people. Now, the government of India has a big push today, for invention and innovation. Why? For sustaining and growth of GDP, for the self-reliance. They have the Atmanirbharta, right? Global competitive edge. They capture the global market, protect from the disruptive technology. You do not know, what we are doing today. Tomorrow, it may be totally useless. And create employment and prosperity. So now learning and innovating is a necessity today, right? And just think about that. Learning is like inhaling, which is important for survival. If we don't inhale the air, we will die. So they go together. Learning is like inhaling and innovating like exhaling. Inhaling is learning, acquiring, creating, sharing new knowledge, and evolving knowledge to wisdom. Exhaling is innovating, generating, deciding, implementing, celebrating innovative responses to opportunities and challenges. Successful institutions, they have a culture of both learning and innovating for their sustained growth. Every company I worked, they spend a sizable amount of their revenues on the education, have a separate department, they hire the professor from outside, expert from outside. So the learning is extremely important if you want to remain in business or whatever you do. And also this is for fun and profit. Every time you learn or you share the knowledge, it's a fun. I'm talking to you, it's a fun for me, right? I'm sharing my little bit, whatever I know with you. It's a privilege. And some we make our living also. The learning becomes more interesting if the purpose and benefits are known. I have been going to different institutes, talking to a lot of students in India, and only complaint I hear from professors is that the students are not motivated. And I also hear from students that they do not know why they are doing what they are doing. So when we are teaching something, we need to give more science and technology than just mathematics. Based on my personal experience in many classes, when I was a student, a professor will come and start solving the equation, giving the mathematics. There was less science and technology in there. I did my first degree MSc Physics, then switched over to technology. In MSc Physics, it was more mathematics, no physics. So you don't know what is happening. So if we do that, then things would change. And create and satisfy the curiosity of the students, right? Why should they study it? And Q&A must be encouraged. This is something many students complain to me when I talk to them. Whenever I go visit any university, I hold a meeting, a dinner meeting, pay for it, and ask the feedback. And they always say that their questions, their queries are not answered. And teachers tell me that students don't ask any question. The thing is think about that. When I was a student, MSc Physics, first semester was devoted, to quantum mechanics. And the subject in quantum mechanics, the professor spent like 2 months on uncertainty principle and quantum wells and did not know what is that. Why should I do that? But when I came to Illinois Urbana-Champaign, the professor Horoniak there, he used the uncertainty principle to develop the first, LED light emitting diodes, visible light emitting diodes, which is still a product today, right? And that's where they use the uncertainty principle. So if I knew that application, I would have appreciated uncertainty principle much more. Similarly, quantum wells. We studied quantum wells, different kind of quantum wells, solved different Schrodinger equations, but did not know why I was doing, what was the purpose. But last 30 years, I spent, growing quantum well lasers, making quantum well lasers, and working quantum well lasers in my systems. So similarly, Raman effect in optics. Did not know what the purpose of studying Raman effect. But today, Raman amplifier based on Raman effect, they are deployed in the network everywhere. The talk or this presentation we are having this morning or this evening, it is going through some Raman amplifiers everywhere in the network. Raman amplifiers are involved. So the Q&A must be encouraged. You have to think about that our all scriptures, I'm talking about Upanishads and Gita, they are Q&A. And like in Bhagavad Gita, entire Gita was finished in chapter 2. But Arjuna kept asking same question again and again in different form. And Krishna kept replying them. He was not angry. Hey, you asked me in chapter 2. You asked me this question in chapter 4. Why are you asking this again? That's for our benefit. So encourage Q&A. That's what I would consider extremely important for learning and innovating. Now, most of you are faculty members, and I'm sure that on YouTube, a lot of students are joining. In the life, the goal of life is to be happy, right? And to be happy, you have to enjoy what you do for your living. Then you never have to work. And teaching itself is a noble profession. You are making a difference in people's life. So make a difference in students' life. Establish a Guru-Shishya relationship like Shrikantji has done. His students have high admiration for him. In Sanskrit, there are 3 words for a student: Vidyavardhaka, Antavasi, and Shishya. And they relate to your different commitments to learning. Vidyavardhaka simply means you are taking the admission, but you don't have to attend the classes, do something. You just say student there, call yourself a scholar. Antavasi, you go there, you sit there in the class, listen everything, but you may not be learning. But Shishya is complete dedication from both sides. Like Shishya, Arjuna and Krishna, I am your Shishya, please reveal my knowledge. And Shishya doesn't understand, ask question again. So I feel that this Shishya relationship must be established. And the work is pleasure, the life becomes a joy. How do we know that we enjoy work? I was listening to few the great Warren Buffett, who is the great investor, and he gave a definition that when you enjoy your work, you want to do it, even if you don't need money or you are not, looking for money. Like I'm doing this or I have been involved with this activity, Prakash Bharathi, not for money, because I enjoy it, because I'm making some difference, attracting people. So this is what is. Now, you could use IEEE as a great resource for learning and networking. At my time, we did not have photocopying machine. We did not have calculators. We had to sit in the library until midnight, go through the journals, making notes, and journals very thick. You can't take them home. But today, everything is online, right? IEEE is the largest organization in the world. It has 420,000 members in 160 countries, 50% outside USA. Actually, India has the second largest numbers. And of them, 25% are the student members. IEEE has 39 societies, 130 journals, transactions, and magazines. And many journals today are open access and free. You can download any paper, you can go. The role has changed. Earlier, you publish free, but when you want to get the content, you have to pay, you have to buy the journals. But today, it has changed. When you want to publish, the author has to pay, and the reader, they get the content free. So just think about it, that the role has changed. Today, the knowledge is coming to you in your bedroom, in your living room, in your drawing room, in your kitchen. So the knowledge access is there, right, everywhere, right? IEEE has more than 300 conferences annually. And this year, thanks to COVID, most of the conferences are virtual and they are free to attend. Only the speakers, the presenters, they make a nominal payment. IEEE has 900 active standards. And this is important. Standards are very important. When you are designing a product, you are developing a product, it must conform the standards. People have done a lot of work, and so standards should be taken. IEEE has like more than $400 million in a non-profit business. They earn money through conferences, through membership, through standards, but all the money is spent on membership, on helping the members. And today, IEEE motto is foster technological innovation and excellence for the benefit of humanity. It is extremely important, right? So they are working really, earlier, the effort was just to create the knowledge, but today to benefit the humanity. So in one of the societies, the Photonic Society, and I'm representing Photonic Society. And by the way, whatever I'll be sharing with you are my own thoughts, on views. They have nothing to do with IEEE. IEEE only provides you a platform. The content is generated by the members, by the volunteers. It is a professional home for scientists and engineers who are working on lasers, optoelectronics, photonics technologies. And Photonic Society has allocated $500,000 for global outreach programs. In India alone, they have funded quite a few projects. Many of them in Karnataka, in Tamil Nadu, and in Kerala. 15 projects have been funded. There's more emphasis on women on photonics, underrepresented minorities, multicultural outreach and globalization with target nations, Latin America, Africa, India. There are 103 chapters globally. Of them, 27 chapters are in India. There are 4 chapters, there are full chapters, in Madras, in Calcutta, in ISC, and in BHU, and 23 student chapters. And I encourage all of you to, if you don't have, open a chapter, because membership fee is very little, but you can request a grant, seed money for different activities up to $2,500. And there are numerous outreach programs for STEM. STEM stands for science, technology, engineering, mathematics. But there is a lot of controversy about this because people want to see a balanced growth. Like in India also now NEP, they would like to have a balanced growth. So actually they have changed to stream, science, technology, engineering, arts, mathematics, and the art stands for writing and reading. But some countries, they demand religion also. Like Saudi Arabia, they are forcing that, hey, this photonics light should be related to Islam, things like that. So science, technology, reading, writing, religion, engineering, art, and mathematics. So this is what they would like to see, and I think the NEP would address all that. So IEEE is working at the grassroots level, to educate middle and high school teachers. We go and we have these STEM kits, and which really within an hour, you can teach the geometrical optics, even to the middle, primary schools. A lot of resources there, webinars, articles, papers on the website. So please go and take advantage of these resources, right? In India, we have formed this organization, Prakash Bharathi. Is anybody in the photonics, whether they belong to SPIE or OSA or IEEE, there is no firewall. Anybody can join, and together, one of the things in India is lacking is the cooperation, collaboration, partnership, and we bring these people together so they can help one another, right? So I welcome you all. I thank you for inviting me, and that's all I had to share, for this part of the keynote talk, and we'll be talking later. So thank you very much.
Thank you, sir. Thank you, sir, for giving insight into the field of photonics, the challenges and opportunities that are awaiting for scientists, engineers, and industries in this field. Now we have come to the end of inaugural function. I now request Mrs. Girijamba, Assistant Professor, Department of EC VVC, to deliver the vote of thanks.
Thank you, ma'am. It's my privilege to propose vote of thanks for today's function. I'm very grateful to our college management for their generous support in organizing this faculty development program. I sincerely thank our chief guest and today's speaker, Dr. Naresh Chand, Life Fellow of IEEE, Associate Vice President, Chapter Relations of IEEE Photonics Society, Warren, New Jersey, USA, for kindly accepting our invitation and gracing the inaugural function. Thank you very much, sir. And I thank Dr. S.M. Prasad, Chairman, BOS, Technical Education, Government of Karnataka, for his presence. Thank you, sir. I thank Dr. Raj Kumar, Senior Scientist, CSIR, Chandigarh, for his presence. Thank you, sir. I am also very thankful to Dr. P.C. Srikanth, Chair, IEEE Photonics Society, Prakash, Bharathi, India, for accepting our invitation to be the chief convener for the program. Thank you, sir. I also express my heartfelt thanks to our beloved principal, Dr. B. Sadashivegowda, for his continuous support in his absentia. I sincerely thank our HOD, Dr. Chandrasekhar M. Patil, for providing us with all possible logistic support towards organizing this event. Thank you, sir. I also thank my fellow coordinators of this event also, and also I thank all those who are participating in this event. Thank you, everyone.
Thank you, one and all. I request the participants not to leave the session. The session will start in another 5 minutes.
So I'm sorry I had gone for a minute. Are you people
Yes.
ready for the talk?
Yes, sir. Shall we start?
Yeah. Shall we start? Okay.
Yes, sir. Just I'll give some. I'll just inform the participants, sir. Dear
Okay.
participants, the session will start now. I request the participants to post their queries in YouTube chat box, and the queries will be addressed at the end of the session. Sir, the participants will be posting the queries in the YouTube chat box, sir. We'll be
Okay.
reading questions and then we'll be telling it to you, sir.
Right. Okay. So I'm going to use another monitor. So let me see if it works. Okay.
Oh, okay, sir.
So do you see my screen?
Yes, sir. Yes, sir.
Yes, sir.
Yes. You
Yes,
can
sir.
see, right?
Yes, sir.
Yeah. Okay. Well, thank you. Thank you for inviting me for this talk. This is the 5th time I'm giving this talk in India, and I put it together. Actually, though the theme of this FDP is recent advances, but my focus is opportunities, because our youth is looking for opportunities, right? So if a lot of advances are taking place, you can go to any conferences and you will see a lot of things are happening. But students ask, what is in there for me? What I can do? So I'll be sharing with you my thoughts about the photonics opportunities and challenges. And of course, they relate to the advances. So as I mentioned that I represent IEEE, but all the views here are my own. IEEE today is working for advancing the technology for humanity, and Photonics Society is working on transforming science into technology. So just having the knowledge is not good enough. We really need to see what we can do with it and how it can help the common man, because when we study, when we go to engineering or college, our education is subsidized by the taxpayer, by a farmer, by somebody working in the street, right? We have to pay back. So the photonics, just you all know that, but just as an introduction, because there may be some people who are not from photonics, but from different areas. So it's just an introductory slide. The light travels as a wave, but when it interacts with matter, it behaves like a particle or photon. Optics and photonics, they are used the word, interchangeably. Optics is to manipulate light through lenses, mirrors, and photonics is meant to generate, modulate, sense, and process photons. A photon has no mass, but it has energy, a lot of energy. It travels at the speed of light, and it can carry a lot of information. Photonics is key enabling technology today, for the 4th industrial revolution. We are at the beginning of the 4th industrial revolution. It plays a vital role in our everyday life, everywhere around us, especially in this COVID-19 environment, right? Because of photonics, we are having this meeting. New technologies and applications, they continue to emerge. So there was a conference called CLEO in July. There were 18 parallel sessions for 5 days. And everything is so great. So all the sessions are recorded. If you're interested, go to the website, register, and you can watch all the programs. They are all free. Most developed nations today have the National Photonics Initiative. Some countries, they call it quantum initiatives, NPI or NQIE. In US, it was National Photonics Initiative. Now it is National Quantum Initiative to provide the photonic solution to the major socio-economic challenges. It's unfortunate that India has no National Photonics Initiative. And that's where you people, Shrikantji, you can play a big role. And I'm available to help you. Photonics offers solutions with low carbon footprint. Energy required, to generate photons, to detect photons, to transmit photons is negligible compared to electrons. Photonics offers big opportunity to India to contribute as well as benefit. India can produce, India can consume, and India can export both products and services. At least India should contribute to 5% to India's desired, 5 trillion economy to create jobs and prosperity. It's unfortunate that India's GDP is down this year, 25%, So the goal of 5 trillion by 2024-25, may not be met. But photonics can play a big role. It requires multidisciplinary science. It has something for all engineering branches, whether you are chemical engineering, mechanical engineering, electrical, electronics, optical. So everything goes in there, right? This 21st century will belong to photons, as 20th century belong to electrons. It requires private, public, and foreign investment. If you see the photonics global market, in 2018, these are the real figure, it was $636 billion and is expected to reach 1 trillion by 2024. And actually, because of this COVID, there is so much activity now all over the world, which requires photonics, requires cameras, it requires more laptops, more TVs, that the number could reach much larger than 1 trillion by 2024. And which was expected to be 1% of the global GDP, that in 2024, the global GDP would be $100 trillion. So 1% would be photonics. And it's like 8% annual growth. Now, if India wants to be leader, at least India should contribute, 10% to this, $100 billion. When her population, India's population is 17.5% of the global population. The number of areas in photonics, display, the maximum growth. Because display, we use your cell phone, we need for television, for your PCs, the information technology, the solar photovoltaics, the production, defense, security, communication, the lighting, the machine. So everywhere, there are a number of applications. In December, I was visiting Surat, a diamond factory, and they were using the laser beam to cut the diamonds, to polish the diamonds. So in India also, the photonics, it has entered into manufacturing. So these are the mature technologies. I put them together. In every area, India can contribute significantly. Very first is photosynthesis, to clean air and beautify our surroundings. This is a big problem in India today, right? We have so much pollution in different parts, right? We can use photonics. Energy. India needs energy. There's always shortage of energy. We need more and more. And this is the clean energy. I think India has a success story. Communication, information technologies. India wants to have fiber to every gram panchayat in India, like so many villages, so many cities. And because of the COVID, actually, it will accelerate everything. Sensing, imaging, the lighting, the display, the healthcare. Photonics is entering in a big way in diagnostic, in therapies, in gene modification, drug development, in defense and security, the LiDAR, light identification, detection, the radar, the VCSELs, vertical cavity surface emitting lasers for the optical interconnect, the data centers, 3D imaging. Each smartphone, the next generation, will have a 3D camera. A camera requires an array of VCSELs, 32 by 32 minimum. That means 1,000 vertical surface emitting lasers every smartphone will have, 1,000. So there would be a demand of billions of VCSELs. Material processing and low-cost manufacturing. Because when you are doing the welding, you are doing cutting. If you are using the old way, the arc, it requires a lot of power. But if you are using a laser beam, you have knife edge beam and you can cut with very little power, very little cooling. See, when you generate the power, you also have to cool the system. So if you are using less energy, you require less cooling. So you save energy from all sides. The entertainment, that your television, your CD player, DVD player, they all use lasers, so they use display. Food preservation and sanitization by UV light. Now, this is a new application appearing, and it is appearing in a big way. The airline now using the UV light for sanitizing the aeroplane. For food, I have slides we'll share with you. The agri-photonics, the smart farming, farming, more food and less cost. 60% of the Indian population is involved with agriculture, and they add only 15% to GDP. The farmers, they are dying, they are suiciding. So we have to reduce the cost of manufacturing, cost of agriculture, and photonics can play a big role there. So I put some numbers here. I did the calculation. You can do your own calculation. You all are great in mathematics. India has a population of 1.4 billion, and how much everybody consumes or what can contribute. And I put those numbers like photosynthesis. Everybody can have, I just put here 2 billion. So if $1.5, 100 rupees, if you could add value 100 rupees per person, you get $2 billion here. The clean energy, India, if it costs like $1 per watt, if India is going to have 20 megawatt power every year, that adds 20 billion. So I put these numbers, and I was putting the numbers without knowing how much would be the addition, but it turned out to be exactly 100 billions what I was thinking. So you see these 14 areas I listed here. They offer so many opportunities, for our youth, for our industry. And you as faculty, you may like to think about, which area you want to focus on and share this knowledge to students, because every time I talk to professor in IITs, Professor Gagan Kumar in IIT Guwahati, he told me students are not motivated because they are not exposed to the benefits it can offer to the society, to them, to their career. So we really need to highlight this. Now, these are the research areas. The previous slide was meant to show you the mature technologies, which are already in the, in the product form. So at the CLEO, I mentioned that there were 18 parallel sessions for 5 days. So these are the different areas, where they were talking about silicon photonics, the new materials and device structures in silicon photonics, integrated photonics, integrating more components, photonics and electronics components, integrated photonics for neural networks and neuromorphic computing, quantum photonics for computing metrology, cryptography, communication, nanophotonics, nonlinear optics, ultraviolet, near and mid-infrared sources and detectors. These are very important for the military, especially because you need night vision cameras, you need to see what enemy is doing at night time, microwave signal processing, photonics, terahertz photonics, or with different sensor applications, flexible display, optics and photonics for agriculture. It was interesting to see that number of sessions devoted to agriculture applications, artificial intelligence for photonics imaging and sensing, free space optical communication. In Indian context, extremely important because we have, mountain range, different peaks. They can be connected through free space optical communication, for electronic warfare. You can have a small terminal there, and you can generate the power also with the solar system. So you don't need power, and you can have connection, gigabit Ethernet connection very easily. You can have electronic fence, on the border. So free space optical communication is extremely important and offers a great opportunity for research and development for the universities and industry, imaging and sensing, and application of these technologies. Now, coming back to China, in China, actually next month in Shenzhen, it was a fishing village, and now it has become one of the largest cities of China. Shenzhen had developed so fast that in China people say Shenzhen is speed. It has picked up a name because industry has come up, at such a rapid rate. All the Apple smartphone are made in Shenzhen. So they have the world's largest expo, sometimes in September. And I have been there 2 times. Whatever you can think of, what's happening in the world, you can see it there. There are different pavilions, it's a huge area, 110,000 square meter, and more than, 100,000 people attended, 1,700 exhibitors. But the point I'm making here is that one expo, actually 4 holes, optical communication, the different technologies for optical communication, the data center, right? Today, whatever we are doing, we have the We have Apple, we have Amazon, we have Facebook, we have YouTube. They have data centers, and they actually have their own network, global network. And data center, the technologies, data centers are so big. Their energy requirement is equivalent to, like, for example, of a nuclear power reactor. You have the laser technology, intelligence manufacturing. It's a big thing in India. We need to reduce the cost of manufacturing. And that's play a big role, laser optical material devices, equipment, infrared applications for sensor, for camera, the night vision. So these optoelectronic sensors for different applications, the fiber sensor, vision sensors, machine vision, the LiDAR, IoT, precision optics, the lens, camera module, different technology. But I want to draw your attention to the last one, because as educators, you must be doing research. And here we have so this is the innovation pavilion. Okay, so this is the advanced system. What I want to draw your attention to: biophotonics, medical imaging. In the healthcare, the photonics is entering in a big way, and healthcare is the biggest cost today. Many of us in USA, we retire, we save money, not for eating. Our requirement, our food requirement, clothing requirement, everything has gone down. But the healthcare requirement keeps going up, right? So people save money so that they can take care of their healthcare. You go to a doctor, it takes a lot of money. Even prescribe a lot of tests, and photonics can reduce all those costs here. So you see biophotonics, medical imaging, healthcare photonics, smart healthcare and endowment, Internet of Things, big data, robots, artificial intelligence. So these are the different areas, photonics, manufacturing, smart healthcare, display module. So these are the new areas where the research is taking place. The university is working on the healthcare in US. If you go many universities, you may find that majority of them are working on the healthcare, some kind of technology healthcare. So the photosynthesis I mentioned now, you may think that, you may laugh that, what is this photosynthesis? What has to do with photonics? But this is extremely important, because our body needs 7 to 8 liters of air per minute. 7 to 8 liters of air per minute, right? To breathe, to survive. That means 11,000 liters per day, per person. Oftentimes we talk about organic food, clean air, this thing, that thing, but we don't talk about organic air. And the photonics can play a big role here, right? Through photosynthesis. You have the water, you have carbon dioxide coming in, and you have the light, sunlight, and you have the oxygen out. So this is what we should be planting trees and shrubs outdoor, indoors to purify air. We need to encourage people in need of extra income to have a small nursery. If you have a maid servant, you have a housekeeper, you have your guard, tell the person to have a small nursery at home. Can buy some planters, have some plants there and grow this thing, and they can sell them, few hundred rupees each. So easily, they can have few thousand rupees per month, income through this making, this small nursery. Think about the farmers, they're dying. They don't have the cash flow. The food prices have not gone up as fast as the inflation. So you could advise them. We have to think about that. We all are crew on the planet. There is no passenger here. We all have the responsibility. The government, Modi, or any chief minister can't do much unless we have to take the responsibility. And this can create a multi-billion-dollar industry. Now, these pictures actually belong to my own house. I have planted with my own hands some 350 trees and shrubs. So this is the backyard of my house. So many trees, all of them were planted with my own hands. I do get a help to dig some holes, but earlier I used to do on my own. This is the front of my house, back. So I planted so many. Inside, on the ceiling also, you can actually hang. I found that at one exhibition that you can have this, and you can put 4 planters, on the side of the window, on inside your on your roof, or your deck, or front yard, backyard. So what I'm trying to say is that each of us has a responsibility to purify air. We can't think that my neighbor, my Bhagat Singh should be born only in my neighbor's house, not in mine. We all are crew, we all have the responsibility. And photosynthesis is an industry where everybody in India could make a difference, could make a living, Now, this is the Maslow hierarchy needs. If you do MBA, go to any management school, that's what they will tell you. That these are the needs, and when industry, they think that which sector they are supporting. These are the basic needs: air, water, food, shelter, sleep, sex, and this safety, security, love, belongingness, self-esteem, and self-actualization. But now a new need has appeared. It wasn't there before, right? When I grew up, we didn't have a telephone. If you need a telephone, you had to book it, and maybe lucky, maybe after 5 years, 10 years, you can get it, and just a telephone, right? And 50% of the time it won't work. But today, each of us need a broadband connectivity, to communicate. And the COVID-19 has expedited the whole process. And this has become a key enabler today. If you go anywhere, people see that, do you have connectivity? I mean, last time Srikanji was making, was telling about IIT Guwahati, we had a workshop, and they built a new guest house. And they booked me in the new guest house, and I went there, and they told me there is no internet there at the time. So I had to switch over and get to the old guest house. Cities here, which have the broadband connectivity, gigabit connectivity to everywhere, there the real estate value goes up 5 to 10%. The industry wants to go there. So this has become the basic need today. People would say there is no connectivity, there is no connection here. So photonics is the key enabler here. Now, I mentioned that we are at the beginning of the 4th industrial revolution. And what is that? There is the fusion of technologies, number of technologies coming together, to making everything smart. And photonics is playing a big role. When we say smart means what? Smart means adaptability, that you can change based on the conditions. You can be a grandfather, you can be a father, mother, husband. What I'm trying to say, that depending on the situation, you can change, like your phone today, smartphone. I mean, think about a smartphone. It has so many things in there. It has, how many radios it has? It has at least 5 radios, right? You have 2G, 3G, 4G, it has GPS, it has Bluetooth, Wi-Fi. So it has multiple radios. It could become calculator, it becomes camera. It could, depending on what kind of app you have, it can change its utility. So that's called smart. Smart adaptability. And it does seamlessly, You don't have to, like radio, you have to tune the station. But it tunes itself. It detects what kind of spectrum is available. It remembers your password. It remembers everything, right? So that is smart. So, and that requires broadband connectivity. I mentioned that. So these are the enabling technologies: 4G, 5G wireless network, big data, deep learning, machine learning, cloud data centers, fast processors, sensors, MIMO, multiple input, multiple output, the optical interconnect. But this is important. This is most of these software-centric defined systems and network. Through software, you can change the role. I mean, even the test and measuring equipment people in your lab, if you are buying anything from Keysight or any other company, today they make a very generic box. And through software licensing, they can change its role. An instrument you buy, it could behave like a synthesizer, RF synthesizer, or it could also become a spectrum analyzer. It could also become an oscilloscope. And so through software, they're just a key. You download the key, and all I'm trying to say that through software, you can have a simple box. And so through software, they're just a key. You download the key, and all I'm trying to say that through software, you can have a simple box. And this is what, when you talk about Geo Network, what Geo Network is doing? They are developing their own, I believe that, I'm told that they are developing their own systems. They buy the black, boxes from Samsung or somewhere, and they are software engineers. And now cost, when the technology is matured, the advantage to India when things are software defined. Now, these enabling technologies, through them, you have the artificial intelligence, the robotics, the drones, virtual reality, augmented reality, autonomous vehicles, wearables, and IoT. Everything that matters is connected to everything else. And that leads to a smart city, smart village, smart street, smart intersection, smart enterprises, smart home, smart living. So the possibilities and opportunities are unlimited. Now, when I mentioned that this is the beginning of the fourth industrial revolution, you would ask that what are the first three industrial revolutions? The first one started when the steam engine was invented in 1765. Then came the second revolution when steel, phone, mass production, light bulb, they came in 1870 through 1914. And the third generation, our generation, ICs, PCs, internet, digital age. But now we are in the fourth, beginning of the end there. You can think about that so many opportunities available there, and we had to adapt. We can't just continue teaching the Newton's law, Boyle's, Charles' law. We had to think what is needed today, right? So this has become the next big thing, applied artificial intelligence. I use the word applied. Unless you have an application, it has no value, right? So now US universities are offering a master course in artificial intelligence, and which is a course supported by the multiple faculties because it requires old knowledge, mechanical engineering, it requires digital signal processing, it requires the healthcare people, biology people, it requires biomedical engineering, it requires the finance people also, your people from the management, the finance people, the transport people, data engineering, software engineering. So this has become sort of a multidisciplinary activity, right? There is no boundary anymore that I belong to electrical engineering, I belong to. So this is the great thing, and India has a great role to play here. One of the challenges India has that our cost of manufacturing is significantly higher, despite the fact that our manpower is less expensive because our productivity is not that high. So this can increase the productivity, reduce the cost, and make us more competitive. Now, this is something I think about in India, that a great application if few people can get together and develop something called divine robot. See, everybody has a temple at our home. We go to different places and we use the deities, their statues. Any question? Any concern? So, if we can make a divine robot, which could be a cool application of AI, right? So everybody could have, instead of having this thing statue made of stone or made of clay or made of plastic, if you could have a real, like you have the Google Assistant, you have the other personal devices. So you could have a divine personal assistant where, not assistant, a guide, right? That you can talk also, you can have discussion there, and essentially to begin with, you can have like, you want to invoke the presence of Lord Krishna or Jesus Christ, or you can have build a sort of any material, a statue, and inside you can put a commercially available like a Google Assistant, and you can talk to this person. And if you can put more functionality like the lips working, eyes working, you can talk. So anybody, like, we go to different places and we just do the go overhead, you can do much more. The robot can know you, can know your problem, can remember everything what happened to you, can remember about your health. When did you take medicine? You did not take medicine, right? So you need to think about that application you can create today. Like you are a senior citizen, right? You are at home and you have problem of your medicines, you forget your memory. So if you can program your television set, if these people want to watch TV, so the TV would ask question, did you take the medicine? Did you take this thing? So can keep an eye on you. So what I'm trying to say is that you can put a lot of intelligence inside your home in different devices. I already have at my home the Google Assistant. I have the smart bulb. I can turn off and turn on light from anywhere in the world. So there are so many applications and you can create this market. So as I mentioned that I'm going to give you the high level description of different technologies, and I'm not going deep into that, because for everything you can find a lot of information on YouTube, in the literature. So I'm changing the subject now is the network. I mean, this is our survival today depends, I mentioned that broadband connectivity. We need broadband connectivity. Without that, we can't survive. We are dead, especially in this environment, right? The world has changed in last few months. Now, just give you an idea here, the network, how do they work? How does my call, how am I talking to you people? How this video is being transmitted. So the continents, they are connected on called submarine cables, this undersea optical fiber cable. So you have on the seabed optical fiber cable, you have big armor, very thick armor, so that the fishes, the seals, they don't bite into it. It carries the voltage. It has a repeater at 50 kilometers apart. So you have this highway, international highway, information highway, right? And the optical fiber. We're going like Africa. Each one has their own name, like you have National Highway number 1, National Highway number 2. So each of them network that is called, they're separate ships there. They put the fiber on the seabed. So this is called undersea cable system. Long haul networks that city to city connected, like Bangalore connected to Mysuru, or Bangalore connected to Bombay or Chennai. So that is called long haul network, city to city. And then you have the metro network within the city. Inside the city, you essentially have, so this is city to city, you connect here 2 fibers, if one breaks, you have the backup. And then within city, you may have a ring that if there's a cut here, signal can go in the other direction. And on this ring, you have the central offices at multiple strategic locations. And this is called metro network within the city. And from the central office, then come the access network. Access network, you come single fiber here, you put a splitter here, and put the fiber to each residence or business. Or can go to hospital, go to bank, or it can go to cell tower. So this is the optical network here, right? You have the submarine network, then you have the core network, and then you have the metro network, and then you have the access network. Now, inside enterprise, big companies like ISA or Bharathi Electronics or other companies, they may have their own network inside, like in the railways or defense, the enterprise network. And you can connect, if your organization is spread over multiple locations, then you could have virtual private network, right? VPN, we call it virtual private network. You can, when you have this connection, right, you could slice it. Slice it just like if you have the railway track, right, from city to another city, you have 4 tracks. So you can say this track is meant only for Rajdhani Express, and this tracks is meant only for the goods train, and these tracks meant for passenger train and all that. So you can split them, right? So similarly here, when you have the network, you can slice it. That, for example, optical fiber, you can transmit multiple wavelengths. So one wavelength belongs to one company, another one belongs to other company. So you can really own one wavelength so you can share it, right? So that belongs to you, that particular wavelength. So there are multiple possibilities here. Within a wavelength, then you can have called time-driven multiplexing, that you have this virtual private network. Now, there is enterprise network. Then inside your home, you have a network that is called local area network. Your different devices, your computers, your router, your television, they all are connected. And then you can have your personal area network, your printer, your computer, your Wi-Fi, so they're connected here. And a sensor network. If you have multiple cameras, surveillance camera, inside the city, you have different camera, different locations, right? They're connected together for farming, different sensors. So this is sensor network. So these are the different networks. Now each network, each thing, whether you are on the transmitting side or receiving side, right? First of all, it's bidirectional. So your phone is a transmitter as receiver, right? So similarly, your computer today is a receiver and transmitter. So this is the OSI model. You have 7 layers, application, presentation, session, transport, network, data link, physical layer, right? So these two are implemented in hardware, and all the top 5 are in software. And that's where India plays a big role. India actually more in application side, presentation side, and has a challenge here, the hardware, because hardware is getting cheaper, faster, and less expensive. But the point is that India, the engineers are needed to maintain these networks, all these functionality, huge requirement. India is a big country, right? So many 1.4 billion people, they all need to be connected. So this offers big great opportunity. Now, I mentioned that the access network, I have been working, by the way, I've spent 15 years of my career, 15 to 18 years of my earlier career in devices, materials, and then there was more maturity. Most of the stuff went to the manufacturing, and I had this challenge. Should I leave? I was used to work in Bell Laboratories at the time. Should I leave Bell Labs, join manufacturing, or I change my field? So I changed my field to the systems, and Bell Laboratories at the time, because there was a shortage of people, so they had their own educational system. So they retrained me to the optical network system. So I changed my field to the network. So since 1996, last 24 years, I have been working on network systems and components for network systems. So I have worked in all these technologies here. I developed the technologies for all these networks. And last 10 years in Huawei, I have been working on the access network. And this is something that India today has a huge need, because fiber has to go to every villages, and every home should have this. And just to give an idea, how are you connected? Just try to understand this slide here. You may think that, how are you getting this? What's the difference between different access technologies? So I mentioned that you have this central office, and this fiber is coming here. So I'm starting from this central office and this single fiber. So this guy here is sitting in the central office, and this is that fiber. So this is that fiber, and this is the central office. So in the central office, this is called optical line termination, and this is called optical distribution network. So you see that here, multiple cards here. Each card has like 16 port. You can get different configuration, but this particular one, this is a Huawei OLT. It has 16 port on one card. So each card here can support, 62, 64, 128,000 customers. So each one will take one fiber. This fiber here will go here. So this is called client side, means the customer side. So this particular unit can support, essentially lakhs of people. In the center, you see these two cards. So these are the different ports here. This is meant for configuration, for managing, for provisioning. And these here 8 ports. These 8 ports, they connect to the enterprise network I mentioned here. So here you see those ports, they go here, but then you have to connect to the network. So these ports, they connect to the data centers or the network, wherever the traffic is coming from. So they connect to the rest of the world, and these points connect to the individual clients. So the fiber comes all the way, and it comes close to your home. No matter where you live, there's your fiber somewhere close to your home, maybe 10 miles away, 20 miles away, or 1 mile away, or right in your home. So if fiber comes all the way to your home, it comes near your neighborhood, and then there you have further splitter, 32, 64, 128, and you can have fiber to your home. Or you can put here, fiber here, this is called DSLAM, Digital Subscriber Line Access Multiplexer. And from there, you can have copper line. Many of you may have the old copper line, twisted copper wire, right? And that is called DSL. So that copper wire comes here. But the copper wire is essentially getting that traffic from this fiber. Then the cable modem, I think, is not very popular in India, but in USA is very popular. I have the cable modem at my home. So in the cable modem, again, fiber terminates here, and this is called DC cap, Distributed Converged Cable Access Platform. and the coax then comes to my home. And the coax has a multiple RF carrier. Some bring the television and some bring the data in, and some RF carriers here, they take the data, upstream. Or the fiber, it can connect here to the hotspot. Hotspot, that is the public Wi-Fi. Or this fiber also connect to a cell tower. And from cell tower, then you are connected wirelessly. Now, many of you may say, hey, my wireless network, is very inefficient, doesn't have high speed. It depends, what kind of, this is called backhauling. This cell tower, when it's connected to the network, what kind of connection, that's called backhaul. So what kind of backhauling you have? In India, many places you have cell tower, and they are connected to the network through an RF link, a microwave link, line of sight microwave link, right? The old fashioned way. And there, your intake, the bandwidth, this cell tower is getting is very limited. So your system is inefficient. But this is connected with optical fiber, then you will have a lot of bandwidth to share. So when you subscribe to any phone company, you could ask them, what kind of cell tower you have and how this cell tower is connected, optical fiber or through copper wire, T1, T3, or it is connected through microwave link, and that will decide you how fast your network would be. Now here, so I mentioned that fiber to the home, by 2025, the goal is AAA, anywhere, anyway, at any time, right? You should be able to connect, right? And fiber to the home, think about that. This year, if you take fiber all the way to the customer, there is no power needed anywhere, right? It is called passive optical network. But if you use copper here, then you need a power here. And if there is a flood or if there is some kind of storm or power failure, then you don't have any connectivity. So they had to have a power generator here, power generator, inverter, you had to do that. So it requires power, and you require real estate. So bringing copper is more expensive. Bringing fiber to your place is very cheap, right? No power is needed. This you can bring in the ground and bring fiber. But here you need a physical location. And then you also need a guard there to guard it. Otherwise somebody can come here, and in India, people steal copper, right? For selling it, right? So they can cut your copper wire, take it away. So you have to have security here. Similarly here, if you are taking coax line, you have to convert optical signal to electrical signal. So you need power here too, right? So here power. So in the greenfield means where there's no network, the fiber is the cheapest solution. So when you have this fiber cable, they look like copper cable, right? And there are thieves there, they cut, to sell the copper. So in some countries, like in Thailand, Malaysia, they always put, there is no copper here, it's all optical fiber, glass, you can't get anything. So benefit of fiber is that it is more secure. Customer will not, the thieves will not cut it. So unfortunately, in India, you have only 1.3 million lines, as opposed to 350 million lines in China. Now, Bharat Fiber, this company of BSNL, and Jio Fiber, they are deploying fiber. But there are different versions of the fiber, GPON, XGPON, TWDM PON, and that's just the technology remains the same. It's just that the data rate increases. Here is 2.5 gigabit per second downstream, 1.25 gigabit upstream. Here, 10 gigabit downstream, 2.5 gigabit upstream. Or here, you have multiple wavelengths, TWDM, that is multiple wavelengths, different colors, you're going down, right? So, and you see that when we compare about China, I don't understand that. In China, 350 million lines, and India only 1.3 million lines, right? And in India, the cost of deploying fiber is the highest, when the labor is the cheapest. So in India, it costs like $1,580 as opposed to $200 in China. And but India has a plan. The Prime Minister Modi, he announced that for this year that every village will be connected, and he gave a deadline also that by so and so date, I think at this end of next year or this year, every village should connect. So I mentioned that fiber and copper, these are the fiber and copper solutions. And then you have the wireless solution. But fiber has to support. You have LTE, LTE advanced, Wi-Fi, and 5G, and fixed and mobile. Many people, when they hear about 5G, they talk about fixed 5G so that you can connect the cell tower directly to your home. So you see that it can create a huge, employment opportunities. And I feel that in India, people should have a test bed, in the laboratory. How does the system work? This is very inexpensive. You can get it free. You can ask any of the manufacturer that, hey, you would like to have. I showed you, this is a very biggest version, but you can get just one port, OLT. And these things are extremely cheap. And you could have, and like Shrikantji was saying that they want to have a polytechnic, train the manpower. So these things are extremely inexpensive today. And they're plug and play, by the way. They are not very difficult to configure. In my lab, I used to have all of it. Now, two things I would like to emphasize for your information. You may think about there is a transformation of communication. And what are the two things? The one thing is the convergence. I just showed that converge. All the technology, they are converging together, right? Whether it's copper, coax, or wireless, or fiber, they all are based on common platform. This is called convergence. Now, many times you may think that, the voice is free, the video is free, the communication we have today is free. Why is that? We have changed from circuit switch to packet switching. Earlier, long back, we used to have circuit switch network. So if you want to make a phone call, a circuit has to be established. Bandwidth has to be allocated to you, whether you use it or don't use it. So that's why you used to pay based on per minute, like $2 per minute to $3 per minute for the international calls. But now the circuit switch had disappeared. It's called voice or IP. It's called packet switching. Ethernet packet. So the packets, they travel and, different paths and they get assembled. And it's possible now, this voice or IP or the packet switching, because the network are faster. The packet, they can arrive because the system, the receiving end has to assemble them and get the information. Each frame, Ethernet frame has a header right in there, right? So if network is slow, then there will be a latency. One packet is coming at time T1, otherwise coming at 2 seconds later. Then you will see a choppy voice or a very slow network. So the two things, convergence, and second thing is the packet switching, that has made a big difference. Now, this packet switching is all bits. So whether it's video, it's data, or voice, it doesn't make a difference. Everything is together. So same device, same phone can work your television. It can work as a video phone, your audio phone, or it can work, can serve multiple purposes. So that's what has happened to the network. So this was about the network. Now, the big thing in India has already announced 99 cities, smart cities. And, the first 20 cities are already, work is going on. But because of the COVID-19, I think this is the positive thing that I think entire India has become smart now, right? Everybody is connected to the broadband network, right? So, see, I'm talking to, all of you, through this broadband network. And the smart cities, I told you that the enabling technology, the broadband connectivity, right? If you don't have broadband connectivity, you are no. Now, this is the vision of a smart city, right? But you may find that it's already happening in this COVID environment. So if you want to see a doctor, you can have a, your virtual appointment, on telephone, doctor can see you physically. You can see the doctor and can discuss, right? So e-health. Electronic health, right? The e-teaching, right? You can have classes now, virtual teaching, right? You can have virtual conferences. The commute has reduced. So you have the new infrastructure. So I mentioned here a lot of technologies, right? Media quality, or you have the many companies providing better video conferences. You have on-demand TV and audio, streaming video. You can watch what you want to watch and not watch company want to watch, right? You have many YouTube channels. So increase political transparency. What I'm trying to say that these are huge number of applications, right? And these applications you need to develop. Now, India has banned so many Chinese apps, right? So I'm surprised that India does not have its own apps. Why do we have to rely on China, right? When we have so much software engineers, so many, and but this offers a big opportunity, and we need to train our manpower just by teaching, the basic laws, etc. Doesn't produce, engineers who can contribute to society. So now I encourage you to set up a sort of a demo in your lab, in your institution, right? I'm trying to not getting the right word. So a test bed. If you set up a test bed, have units there, then funding will pour in. So there is here in Rutgers University here in New Jersey that is called WIN laboratory, right? Wireless laboratory, and they get funding. They are applying for every contract, big contract. Why? Because they have, if you go here, they have a huge test bed. So when they call the funding authority, they show it, they feel that these guys are doing something. They know something. So if you don't have anything at your place, and then nobody would give you any funding. Many people complain that only the IITs and big institutions, ISC, they get funding, other schools don't get, because you have nothing to show. So if you have a smart city test bed, set it up and see what are the different possibilities. Then the people would be trained and they would find jobs very easily. And you can invite the chairman, mayor of the different towns or the pradhan of the villages, show them what you can do with the technology. So you can create, millions of jobs and opportunities for our youth, our engineers, our scientists, our even the technicians. So all I'm trying to say is that we really had to provide some practical knowledge. And time is now, because you can do it and students can feel it, they can put their hands on it now. If you are doing something, I think you would be, because if you are talking about the smart home, smart cities and all that, so data has to be generated and it has to be transmitted, it has to be processed. And for that, there are multiple technologies, the wireless technologies for sensors, smart enterprises. Bluetooth, your Zigbee, Z-Wave, Wi-Fi, LTE. LTE is the unlicensed band, So the enterprises are trying to get in there. And this is meant for data acquisition, and these are the small boards, you can buy them, they cost very little, there are many people selling them, there are different names there. I'm not, this itself, when you go to Google, you can find out for each what are the things available very inexpensively. So they have the data acquisition board they have inside ADC, analog to digital converter, analog converter, DSP, digital process, and a little antenna, amplifier, power supplies. So you can buy these cards, and based on that, you can build a prototype. So if you are building sensors, building a sensor is not a good enough. You build a little prototype, show them, how does it work, right? So at my place in Bell Laboratories, when I was working, a group, they developed the QUIP, quantum well infrared photo detectors, long wave infrared detectors. So they detected this and they wanted to show the app. So they put a commercial camera and take the sensor out of that and put the new sensor. So many times you can demonstrate your technology by buying a commercial thing and replace things which you are developing, remove the old stuff and put your stuff. So, so you really, we have to really train our engineers today so that they can make their living and they can help the system. Now, this is a disruptive technology. At CLEO, first time I heard about it, and I encourage you to go to CLEO and see this flexible display. So you could have a display, on your shirt, on your television, on your refrigerator, on microwave oven, whatever, on your car seat, so anywhere. So it will take the shape of where you want to put it. Okay, it will provide you a fully flexible display, and fully sensor network. So a smart home, the sports and the fashion, office, education. So this is a next generation human-machine interface technology that will transform the way people experience and interact with the world. So this is something that you may like to watch it. Say it's very the best talk at CLEO. And it's a very sophisticated technology. You have multiple layer of devices, you glue them together, and that's how you make the flexible display. Now, since you are from Karnataka, and you have the NAL, HAL, you not very far, they make the submarines or ships. This is slide, it shows that the network on a jet fighter, for example, right? They also have a local area network jet fighter. And earlier, for example, this is a cargo plane C-17, earlier company I used to work at, BAE Systems, I used to work in this area. So I had a contact from Air Force. So this used to be the, it's a cable farm. It's just supporting only the vehicle management system, very thick cable on a plane. But now it has all been replaced by fiber. So the weight has gone up, the plane are much lighter because all those copper wires have gone, and replaced by optical fiber. Just to give you a feel what is involved in there, right? And you all can contribute in there. So you have a optical backbone network in there, right? Optical fiber. You had to have triple, at least redundancy in a plane, right? If one fails, you have something else to take over. So you have a backbone network, and it is connected to different parts of the plane. The top one is the identification and surveillance network, right? You need to have the radar, synthetic aperture radar, hyperspectral imaging. This is EO thermal vision at night, night vision, so that plane can see everything at night. So when you have the camera there, so you're getting so much information, right? Because you are continuously taking the photographs at the speed of the aircraft, right? You had to have gimbal so that the image remains stationary, and all the data has to come, and it has to come here, and then it has to transmit to the command and control center, right? So you have to have communication network, and they have different network, maybe a satellite network. If your plane is in India and it has to go to, information has to go to US, then it has to go to satellite, and different band, K band or Q band, or the common data link. If you have a plane there belong to Army, it has to communicate with Air Force or with the Navy. So this is called common data link, means all services, they support it. And then you have different radios. It's called joint tactical radio systems, right? High frequency, very high frequency, UHF. So point I'm making is that again, this stuff is connected with the optical fiber. If you use the copper fiber, the copper cable, then the weight is heavy, power requirements are huge because signal attenuates. Here, signal does not attenuate, right? Then you have the storage system, file server, you have to store the data. You have the display, you have the navigation network here. But the most important thing is that electronic warfare network. So the electronic warfare, means that, what is electronic warfare? Electronic warfare is that you have the access, you have the control to the spectrum, and the enemy does not. And the optical fiber, optical communication, that provides that, right? Because in the field, if you have, for example, you have a conflict with China or Pakistan, so you can have your own optical. If you have connectivity with optical, like you can have a binoculars. And if you can see each other, right, through binocular, you can communicate, you can have an optical line of sight beam in there, right? So the electronic warfare, electronic attack means you don't allow access to the spectrum to the enemy. Protection, you have to protect your spectrum and support. So what I'm trying to say that there are so many things go inside a plane, and same thing go inside a ship or a submarine system. In submarine also has to communicate to the surface. So there also is called optical wireless connectivity, and for that 532 nanometer, wavelength, minimum attenuation in water. So there is a lot of activities, a lot of research is going on optical connectivity with submarine. So you people, because you people are at a strategically located where you have the end users, the satellite people. I was visiting ISRO in Trivandrum last December, and they're putting optical fiber on the satellites. And one of the things they were asking is that one of the problems they experience is that they have a lot of sensors on satellite devices. Their property change with temperature. How to compensate that? Of course, digital signal processing is one technology where you can do the mitigation of those changes. But anyway, this is what I'm trying to show you, a big applications where now this technology, I'm told that now they have their own universities, they teach their own people. And but I do not know how to address these issues, but I'm just exposing you because you are the educator and you are beginning, many of you are young and you are starting your career. So I'm just giving you a feel. This is another huge area, this infrared sensing, because India is surrounded by enemies from everywhere, right? Not only outside, but within. Inside the country also, you have people who wants to destroy the country. So you need to do the surveillance 24/7. And for that, you need to have infrared sensing, means that you can see at night time, and that means you need to have a longer wavelength. So there are, and you have to use the wavelength where the atmospheric absorption is minimum, right? So there are windows, where you can transmit. So there are different windows, right? Near infrared, short wave infrared, you have medium wave infrared, long wave infrared. So different applications. And for that, you need different detectors, right, for making the camera. Mercury cadmium telluride is something that with solid state physics laboratory has been doing that, making it, I don't know now, but 25 years ago, they used to do that. And you can change the mercury content in there to get different wavelength, But now they are using, bulks, 3-5 semiconductors, indium gallium arsenide base or indium antimonide base. And now these type 2 superlattice infrared detectors are becoming more popular. This is a slide I've taken from a friend from JPL, So this 3-5 semiconductors based on antimonide alloy superlattices. So these are different pictures at different wavelengths, you can see that the properties, how do they change. So this is one area that that if you buy these cameras, infrared, these cameras, are quite expensive, The military must be spending tons of money on that. And the local scientists, engineers, they need to really develop this technology. The LiDAR is becoming a new technologies, which on YouTube, if you watch, there are a lot of video there, very interesting video there. It will be used for autonomous vehicles, agriculture, river survey, modification, modeling of the pollution, archaeology, and building construction. So when this is based on optics, light identification and detection, the radar. So the ranging. So here, autonomous vehicle, they would be using a few thousand vertical cavity surface emitting lasers, right? Everywhere you would be using the laser beam, using the detectors, and it offers number of opportunities. Now this new application, agri-photonics, right? Precision agriculture. And photonics technology are helping the farmers, the food processor and famine plague area of the world to increase productivity, reduce the cost. Because farmers in India, they put too much fertilizer, thinking that feed too much and they would get better yield, but it works sometimes the other way. When I first came here to my house, I put a lot of fertilizer on some trees I planted, but they died because I put too much fertilizer there. So they just like you eat too much food, then you will become sick. Same thing goes with fertilizer, and photonics can help here. It can monitor, observe, and measure the crop health in real time, and increase productivity and quality. It can predict the protein level, determine optimum harvesting time, map the water quality, screen crop for contaminants, monitor overall soil health, detecting invasive disease, irrigation level. Many times people do too much irrigation also, right? Maybe land doesn't need that much water, but they keep, and that costs money, water is not free. And the fertilizer effectiveness, take precautions where necessary. So the global spending would be like $30 billion on the agriculture R&D itself, right? So as I mentioned in the beginning, that India has 60% population involved in agriculture. That includes, the businessmen who sell the agriculture product, the people who bring the vegetable to your doorstep. So it includes all of that. But they add only 15% to GDP. And I think maybe we need to reduce this number and increase this number, right? So this thing is that India, agriculture country, right? So this is something that needs to be addressed, right? So this is one area which is appearing and growing. I think at the very beginning, and India could play a big role here. And this is using the farming with LEDs. I mean, many times land is disappearing, right? I'm wondering that people can grow things in their basement or under the house. You can have, make a basement, and there you grow your vegetables under your house. And all you need is that blue and red LEDs, right? And they have been found extremely effective source of light for indoor farming. And they are in Taiwan, Japan, they are doing a lot of work in this area. The red LEDs, they promote root growth, and blue LEDs, they promote chlorophyll production and leaf growth. So if you go under your basement, right, you make a area, under your floor of the house, and you can grow, underground this, right? These LEDs are very cheap, and you could have this. So many times students looking for projects, what project we should do. Ask somebody to do this project, get a red LED, blue LED, and develop a small farm. The farm doesn't have to be very big. It could be like 1 foot by 1 foot, They could put it somewhere under dark, make a big hole in the ground and cover it and, make it. So people should put their hands on. One of the things in India is that because we get so much help, we are maid servant, you have something, somebody is cooking for you. When I go to India, visit people, they have servants who carry my little bag also, In US, we do everything with our own hands. So you need to train your children, your friends, yourself, doing things with your hands and doing things, and see if you could grow some, allow the students to do something, make a small, a big thing, because if this happens, because the land is disappearing, right? Agricultural land, right? Everywhere, land acquisition for building roads, the industry. But we all need food. We need fresh vegetables. Can we grow vegetable at our own home in the darkness, right? So maybe under our bed, we can grow vegetables. So anyway, this is one thing. This is another area, which is picking momentum. You can go to Amazon and you can put the UV sanitizer, and you will see hundreds of products shown here on the right. So I think that time is not very far when each of us will be carrying this, because this will be used sanitization. So if you are going in the train, you will be sanitizing your seat. If you are coming to your office or you are going anywhere, so you will be sanitizing this, right? So this UV sanitizer, I was watching just the TV 2 days ago that American Airlines, they have this UV sanitizer throughout the plane, because if you use chemicals, it would be expensive, take a lot of money. But here you just go there and kill it. So this is 3,5 nitride based UV LEDs and lasers between 200 400 nanometer. And this is a great research area, enormous potential to sterilize water, air, food, for 8 billion people in the world. 50% of the food is wasted. It gets destroyed, Every week we throw a lot of food because we don't go to market every day. We bring the vegetables, can't eat much, and it gets spoiled. But here is an example here, right? Without and with the UV LED for 8 days, Here nothing happens, and you see it's fungus here, right? And this UV, you have different bands, You have UVC band, BC band, B band, A band, and they have different applications, right? So right now they use mercury lamp, but mercury is very toxic, is fragile, it's a short life. But if you can have an LED-based, develop LED, it could be eco-friendly, robust, and have a very long lifetime. So, but UV light has multiple applications. It can also be used non-line of sight. As you know that light is scattered, right? Inversely proportional to the wavelength to the power 4. So UV gets scattered, at the highest rate. So it does not require line of sight. So you can have a hand terminal and the light would bend, scattered and can hear, can have communication in the room. So even the field, if we have our soldiers, our troops, they want to communicate, they don't need to use RF because the enemy could detect the RF signal. But this one is the optical signal and reach is limited. So you could use this for non-line of sight communication. And the water purification in the agriculture, for your refrigerator, your dishwasher, for your medical, food medical equipment, 3D printing, UV curing, tanning, lithography, medical applications, plant lighting. I mentioned that you could, sensing. So the security, the multiple applications are appearing. So you have opportunities for making LEDs, making the product, and exploring the applications. So if you have the educators, you have undergraduate students, and they are looking for projects, assign them project. Hey, buy this UV, this light. You can buy from Amazon, very, very inexpensive, $30, $40, $50. You can buy it, right? And ask them to take some applications, that study, effect of UV light on the curing the, the water, or they can have a control sample and sample under test, and can see the contamination in the water or whatever. Anyway, you can create multiple projects. Many times educators, they face this problem: what application, what project I should give to students. So from this slide, you can get hundreds of projects for your students. In the healthcare, the diagnostic devices. So we have, for each body part, there's a optical device. And I'm not an expert in this area, but if you go to SPIE has a poster, and you see that how many devices, how much things, and many of these things they can build. So when you are teaching your engineering students, ask them to build something, right? Some of these things I mentioned to you, that you can get the data acquisition board, you can put things together, build prototype. Some of the things you can build in your lab if you have the infrastructure, right? And for that, you need collaboration, partnership with other schools, work together. One school may be good in one area, other school. Right now, I mentioned in the beginning, we are all our crew. We need to help the country. We need to increase our GDP, because if everybody is prosper, we all become prosper, okay? This is a success story in India, solar power, right? And the solar power is, India, I believe that want to produce 100 gigawatt by 2022. You can appreciate what is gigawatt, I mean, for example, if you have your bulb, right, 10 watt bulb, right? So the 10 watt, you can divide this 100 gigawatt, 1 gigawatt by 10 watt, you can see how many bulbs you can light. Now, when you say 100 gigawatt, it means instantaneous power. So I believe that by February 2020, 34 gigawatt is already achieved. It's now cheaper than coal-fired system. It creates no pollution, no healthcare issue, right? It costs only $1 per watt. And 1 kilowatt plant, if you have it, just for your idea, knowledge, it can produce 1,500 units per year. How it is calculated? Think about that. In 1 year, you have 365 days. Then the sun, you can think about that. Okay, you will have 300 days sun and 5 hours a day. So that means 300 times 5 hours, 1,500. So you multiply 1 kilowatt by 1,500. That's what you get, 1,500 kilowatt hour, per year, and that's 1,500 units. Solar, you can put solar plants on your rooftop, on electric poles, on highways, canals, rivers, lakes, and bridges. Now, I was visiting this new memorial has come up in Navsari, where Mahatma Gandhi started with this salt movement, Satyagraha, Namak Satyagraha. And I visited that. I was curious to go to the Statue of Liberty and this national monument. I went there. I was so impressed, They had these solar trees there. This is in India. This is in Navsari, in Gujarat. There are 41 solar trees there, right? And they're producing 182 kilowatt power here. In Bangalore, this DAL unit, they have the solar panel on the vertical wall, right? Not on the top, but on the vertical wall. And when you have the panel, you reduce the requirement of heating and cooling inside. In Gujarat, they have this solar system on a canal. Now in Kerala, they have built this solar plant, floating solar plant on a lake. And in UP, they are building a solar plant on this Rian Dam, will produce 150 megawatt, at the cost of 750 crore. I showed you that on my own, some years ago, I started, I felt that I should have solar system at my own home also. So I put a solar system on my roof. You see the solar panel here, 5 kilowatt system. So I generate my own power, and I recovered my cost within few years. And now I sell some certificates and I make money. So anyway, each of you, if you have place to put solar panels, put solar panel, be a contributor, right? So my spiritual teacher, Swami Dayananda Saraswati, used to say that in a cow, eat grass and, converts to milk, right? And other useful products, right? So even an ant is helping the environment, taking the fertilizer deep in the soil. Everybody is working round the clock. We all need to work, help our environment, right? We have the duty, right? We all have the responsibility. The government can do anything. We each have responsibility. So I have 40 slides. I finished 25 slides, and these were all about the technologies. And I have some slides here which really focus on the other, what's happening. So the technology opportunity is over, and I'm starting the other part. So there is a change of industrial culture today. Until 1970s, I'm talking about in US here, but that reflects all over the world. Until 1970, there was a big emphasis on research, R, big letter, and less, on design, development, all that. In 80s, because many technology matured, so there were equal emphasis on research and development. I have been working on R&D in Bell Labs. I was in for 18 years, and that's where I was working on R&D. But that's how in Bell Labs, they hire you to do something, but they let you do what you want to do. Once you join, they give you a room and they give you a budget, they tell you money, and then you decide what you want to do. And then in 90s, the effort became more on development, less on research. So because what you had developed, you had to create a product. You had to make money, otherwise you can't survive. So the company used to spend 1% of their annual revenues on basic research. Take example, AT&T at the time. AT&T has a revenue of $30 billion. So they used to spend 10% of the total on R&D. That is $3 billion they used to spend on R&D. And of that, 10% or 1% of the total revenue on basic research. So in Bell Labs, we had a budget of $300 million, and we had 1,000 people. And so that's how, like people like me, I used to get like $300,000 per year for my work. $200,000 for my salary, benefits, and $100,000 for my lab. But that has changed now. Now, is more efforts on development, less effort on research. But in 2000, that further changed. There is less effort on research and development. There is more effort on integration and services. Many companies, they say, hey, we can buy the cheap parts from China. We can buy the cheap stuff from other places. Let somebody else do the dirty work. We will buy these things, we will integrate it, and we will sell the services. So company like Cisco, many companies, that's what they do. Madam Thatcher in England, she destroyed the industry. They said, we will provide only the services, the financial services, insurance and banking and blah, blah, blah. So that emphasis changed. Everybody wants to be cheap. Nobody wants to be Indian anymore, in the West. So they transferred all this stuff to China and Thailand, Singapore, Malaysia. And now we are all crying. We are saying that China is giving it, is a threat to us because they have taken it over. But India is in a great shape, can take benefit. But what is happening is that many times we are still working on the research and publishing paper has no value. So we need to change that part, right? So integration service, there's big money here. There's a lot of value added here. You buy the cheap part for $10 and you add, integration and software, it becomes $100. Today, there are foundries for materials and crystal growth, assembly, packaging. You don't need to have a crystal growth facility. You have companies founding in the world. you can buy the crystal. You don't need to spend like $1 million buying a crystal growth machine. Most system companies in the West are now design, development, integrated center. You go to, like, for example, Apple, they don't assemble the Apple phone, iPhone at their facility. They get it done by Foxconn in China. And so they are just design development. Cisco has no manufacturing. Many companies making the semiconductor chips, they're fabless. They get things, they get the wafer from somewhere or they get fabricated from here. So many companies making more money by system, fusion of technologies. Outsource manufacturing, and that's a big benefit to India. Now, if as an educator, if you enjoy research, then you stay with academia. But do good physics and further the scientific knowledge. Develop prototype. This is very important. Develop prototype to test your concept and transport science into technology. Have an end application and customer in mind. It's a big plus. When in December I attended the conference in IIT Guwahati, I met students. What are you working? I'm working on terahertz technology. For what? They did not know. I said, find out what you are working for and don't say I'm working on terahertz. You say, I'm working on terahertz technology for this application or that application. The application has to be, at the beginning. Because today, if I go somewhere, people complain that they are not getting funding because you want to do things just for sake of doing, producing PhDs or teachers, but that's not enough anymore. Any funding authority will ask you, you want money, what do you want to do? What will you produce? So these are the answers you must have. So now what are the major driving force? Today, when you're talking about opportunity challenges, the cost is on the top. Low cost, low cost, low cost, low cost. Every year you want to see cost going down. And that's where the China is winning. Because those guys, they take the cost out. I was working for Huawei and one of my main tasks was how to take the cost down. How to reduce the cost 10% every year. What are the component costs? How to take them out. So want to put more functionality at reduced size, weight, power. So this is the metric. If you go to any defense organization, then defense organization, if you can reduce the size of anything, right? Like radio, a soldier carries a radio. It weighs so heavy, 60 kilograms, 50 kilograms. Those radio is supposed to work. Even if you drop from an aeroplane, it should work, right? So if you could reduce the size, weight, power, then it's the big benefits. And that's what, you have the iPhone, right? They addressed size, weight, power. And then the next thing is quality of experience. You want to buy an iPhone because of QoE, not for the cost. Cost is very high, but the quality of experience is very pleasant. You get continued innovations with friendly human interfaces. So this is most important. How people interact, input, output, because you can by touching, by just speaking, voice recognition, you can accomplish a lot of things. The quality of service, right? So today we are in a global village, design, development, manufacturing, and marketing across the globe. Doesn't have to be at your place. And as this particular talk, we are communicating, 8,000 miles apart. So you can get anything done anywhere, right? Shorter product development and lifetime cycles, right? For 80 years, telephone did not change. The telephone remained the same unit, which people use as a hammer. In the family, one spouse was angry, will throw the phone, and the damn thing would still work. But today, the phone, every year you want to replace, this is version 9, version 10, 12, 11. So people pay $1,000 for quality of experience, right? The product development, every year you need a new phone. So that has reduced. And that's where it's good and bad, both, right? Engineers, they dig their own graves by perfecting that technology. But at the same time, new technology appears. So they always have the new applications, this thing. And we have global competition. This is a challenge. So on the other hand, this is a magazine I got it from this called published LED World. I think this is a magazine, LED World, on 2nd April 2019. And there's a company in Calcutta called Indo-Japan Horologic Private Limited. They make the LED chips. And the reporter asked, why is LED manufacturing not being able to pick up in India? What we can learn from China? And it's important for all of you. And you all have to address this. Modi cannot address this. You have to address. You are the crew. We have a long way to go. For example, in China, you can fill a big football stadium with technocrats. While in India, we can't even fill a small room. That's where we are lacking. While setting up the LED business in India, we had to train machine operators. And it took us a year to do that. If we had to roll out production capacity in China, the manufacturing would have started as early as on the 4th day itself. This is not from me. This is from the magazine, the CEO of this company, he's answering this question. And we really need to address what is lacking. We need to find answer, right? So now what are the problems about the cost, reducing the cost? You need to understand the photonics, the limitation of photonics. In photonics, the device size does not reduce. In the case of silicon, we can keep putting more and more silicon transistors, on 1 millimeter square, right? Because you can reduce the device dimension, it's a scale, but photonics does not scale. Why? Because you need minimum volume to generate light or detect the light. The laser cavity length cannot be too small because we want to get certain power. One atom can produce only 1 photon, or 1 atom can absorb only 1 photon. So if you want to get more light, you need more photon. And more photon, and more photons if you need more atoms, and that means you need more volume. So device do not scale. A photonic device is a 4-particle device. The silicon, when you have device, like most device, is a single particle, electron or holes, or at the most electron holes in CMOS. But in photons, in photonics, we have four particles. You have electrons, you have holes, and you have photons. And you also have phonons, right? You generate the heat, and which is quanta of the heat is phonons. We need to couple the power into the light, into the device, or you get the power out of the device. And for that, you get to do the facet coating. You need to have very clean facet. And you need 3-5 semiconductors. Silicon is the indirect band gap. When you have a transition, your momentum and energy both need to be conserved. And that is not conserved in silicon. But 3-5 direct band gap semiconductors, their momentum as well as the energy, they can be conserved. So you can get light only. So many times people are fooling in silicon photonics. Oh, we will make silicon laser. That's all bullshit. They are fooling, and people get, and get funded, very easily. But no light can come from silicon. And because it's indirect gap, it cannot also be a good detector. It can only be, of course, you can make detector, but but for a different wavelength, not for communication. And it would be, for application where you don't require very fast devices. So very fragile 3-5 semiconductor substrate size is limited. Earlier it was 2 inch. Most of the fabs are 2 inch, but now 4-inch indium phosphide wafer available, 6-inch gallium arsenide substrates are available, and 6-inch used for vertical cavity surface emitting lasers. The indium phosphide lasers and detectors, now they are made on 4-inch wafer. And you can now get it because the processing technology improved. You can get a DFB lasers or a detector for $1 chip I'm talking about. So you have 2, 3, or 4 elements, from group 3, group 4. And because of that, this volatile, it get decomposed with high vapor pressure. And because you have so many up to 4 elements, they are alloys. And you could have stoichiometric defects, means you need to have exactly 50% group 3 atoms, exactly group 50%. But if you don't have that, you have vacancies. And the vacancies act at non-radiative recombination centers. And that's where the phonons come into the picture. They generate heat. P-type impurities in 3-5 diffuse very fast, very difficult to control. So the integration in 3-5 is not cost effective. So we talk about integrated photonics. That's very good, and it's keeping engineers busy. But what happens that at the end of the day, because if you are putting several devices together, then the yield goes down significantly. If one device doesn't work, you have to throw away everything. So you find that the companies, they develop the integrated circuits, they spend a lot of money, and it works fine, but they find that they can't sell it because the customer finds that they buy the individual devices, they are cheaper and they are better, they are more reliable. So many people will fool the funding authority. Oh, we will integrate laser, detector, everything on one chip, but that all again bullshit, because lasers and detectors, they are totally different devices. They require different growth structure, they have different bias, one forward bias, one reverse bias, one high voltage, one low voltage, one emit light, one absorb light, and the different structures, they can't be integrated. And there's a crosstalk. Crosstalk means what happened in one device, it affects the performance of other devices. There's a crosstalk, electrical crosstalk, there is optical crosstalk, there is a thermal crosstalk, and you had to launch the signal, attenuation, lack of amplification. In electronics, you can have an electrical amplifier, but here you don't have that. You have to have amplifier. If you want to put optical amplifier, you have to have some erbium doped structure, which requires more area. So electronics and photonics, they have different growth and processing technologies. So the integrated photonics it has some niche applications, but at the same time, I'm just highlighting the challenges here. Okay. Now, economics and physics challenges for integrated photonics and photonics on silicon. I mentioned that the communication laser detector can't be made on silicon. Okay, you can make lousy silicon germanium detectors on silicon, but silicon is used, the passive components, modulators, and which occupy the large real estate. It's very important to understand that electrons is very skinny. So deep Broglie wavelength of 1 electron volt, is only 1.23 nanometer. That's why you use electron microscope, transmission microscope, because, or you use the electron beam lithography because it provides high resolution, right? And because of that, with 7 nanometer CMOS technology, 100 transistors can be packed in 1 micrometer square chip area. So you can integrate 1 billion of transistors in just 1 millimeter or 1 millimeter square chip. Whereas in photonics, you need to have chip area minimum 250 micron by 250 micron. But I mentioned that electron is very skinny, but photon is very fat, 1,000 times fat, which you may find difficulty because photon, you say there's no mass, nothing, but 1 electron volt photon, right, has about 1,000 times larger wavelength, 1.24 nanometer, which is 1,000 times of this. So a typical photonic component can't be made much smaller than the wavelength of light. So if you are making a waveguide, you need to have a dimension which is larger than this. But if you have the electronic wire, the dimension of the electronic cross connect is very small. So this is the problem of physics. There is no Moore's law or advanced photolithography which can help here. So it will be very expensive to replace transistors with lower functioning photonic modulators. So everything has its own place. Photonics do something good, electronics do something good. So things which can be done in electronics should be done in electronics. Things which can be done in photonics could be done in photonics. So photonics on one wafer, electronics on another wafer, that's the way to go. And you can house them together in the packaging. So the packaging, has become very sophisticated. So you have the photonic devices, your DFB lasers, your EML or FebriPro lasers, pump lasers, photodiodes, and you have the passive components, you have the capacitors, thermistors, AWG, lenses, and photodiode array or VCSEL array, laser driver. See, the laser also doesn't work by itself. It needs a driver. Photonics itself cannot work. It needs electronics. So photonics, electronics have to be together, right? So you need a laser driver. If you have a detector, you need an amplifier called transient impedance amplifier to convert the light into electric signal. TIA is called, right? So these are the basic components, right? And you put all these components as carrier on a chip. You put these components, you have this thing here and the contacts here, and multi-die on multiple devices. You can put this single device and you can integrate them. This is called laser or photodiode on TO carrier to TO header, or you can have a PCB. And these are the, laser or TOSA, ROSA, this transmitter optical subassembly, receiver, modulator. So then you put these devices, and these packaging itself are very expensive, by the way, because they are made a gold-plated enclosure, These are hermetically sealed, the contact. So each of them may cost you $100. So people are moving into low-cost packaging, the TOSA, ROSA, like this. This is this called the optical this the active optical cable, So you put on both ends, looks like connector, but is inside the transmitter receiver at both ends. So this is what's happening that. And what are the challenges? Everywhere you require reduced footprint. I told you the size, reduce the size. Because you can put more components on board, then you can reduce the size of the board, and the end product could be much smaller. Simplify the electronics. Electronics needs electricity, power, and heat it generates, and removing the heat becomes a problem, right? Reduce the number of components, optimize power dissipation, avoid crosstalk, simplify packaging, and your process should be scalable, repeatable, and power efficiency should be hard. And so all these factors are extremely important, right, in the packaging. So now, what are the challenges in India, which are specific to India? And we have here Prasadji, Rajkumarji. I mean, this is something that might be of some interest to them. The problem in India is that we have the lack of technology and facility awareness. Government of India has invested quite a lot at different places, and people are not aware. Or if they are aware, they don't approach, they don't ask. With the result that the facility on the other side, who have it gathers the dust, and the warranty expires. So there's a lack of that, right? We set up this Prakash Bharathi thinking that it can create more awareness, people can come more forward, tell what they are looking for, and other side can tell you we have it, but unfortunately it is not happening. People don't open their mouth, they are not coming forward, But this is the problem. I see that technology and facility awareness, like Government of India has set up the nano fabrication facility at IIC Bangalore, IIT Bombay, and other places. But at the same time, when I meet the students, they claim, oh, I can't produce this, I can't do this, I can't do that. So I'm working on this, setting up a group, like 2 weeks program on hands-on device fabrication program. If any of you or your students interested, can contact me, about it, and it will be funded by IEEE. I'm trying to get some money from them. So there's a funding issue. People complain that's only some institute get funding, others don't get. And I think problem is that many times you don't have infrastructure, or you don't have prototype, you don't show anything. And that's how you have to create, perception that you can do this. The infrastructure and culture for product development is non-existent, unfortunately. Experimental facilities and their maintenance in universities is also a big problem. In one university, I wanted to donate some equipment, and they told me that, hey, who will maintain them? Where will you find the place to keep them? Where will you get the power? They will have to hire a technician. Other thing is that the ownership. When you buy a piece of equipment or something, who owns it? I found that somebody decide if you buy like an expensive equipment. Rajkumarji can appreciate that. A long time ago, I'm aware of that CSIO Chandigarh and Samir in public sector undertaking under MIT, they bought MBA machine. So somebody decided what machine to buy. A totally brand new machine from, I think it's Finland or one of those countries, which nobody had bought before. They bought these two machines, very expensive machines, and totally wrong machines. And so somebody took a decision, and then somebody went for the training, and somebody else actually ended up using them. There were total disconnect. And I actually went on a United Nations project called Talkton to Samir and I did a lot of, provide them a lot of help with that machine to become operational. But what happened that ownership, when somebody else take a decision, somebody else buy it, somebody else go for training, somebody else go for accepting, somebody else uses it. So there's a disconnect there, and then they pass the blame to one another. So here in US, there's ownership. When I set up my first lab with MBE machine, Bell Labs gave me about $1.5 million. And I decided what I need to buy. I decided from who I need to buy. And because they told me that if the machine doesn't work, nothing would happen to them. There were other machines, other people working, but my career would be destroyed. So I had to take care of everything. And I had to consult a lot of experts and figure it out what I buy, how much I buy. The collaborations and networking is lacking in India. Industry-university partnership is lacking. And there is a trust in business is lacking. People think that a businessman is a thief. And urgency is lacking. People think that, hey, there is no urgency. It's sab chalta hai. if we are unable to complete in this lifetime, there is another life. So these are, I find that when I have worked in India, because I used to work, I visit all the industries and R&D institutions, and I find the culture is still, same. It has become a little worse now. There's a misuse of funding. If you give some money, then people do not know what to buy, and they end up buying something because money would disappear. Then they end up buying their own equipment, and more interest in journey rather than the destination and results. So my senior boss, Kumar Patel, he was the head of this particular panel, which Prime Minister Rajiv Gandhi has set up for the semiconductor industry. And they produced a report, and that didn't go anywhere. So I was asking Kumar Patel, what happened to that? He said Indians are more interested in journey, in the process, creating report, blah, blah, blah. But they are not interested in destination and results, So our focus should be more destination results. People look for reasons for not doing things. Too much politics, and mostly theoretical, sometimes irrelevant work, teaching and research, and not many industries to absorb the manpower generated. So, by the way, this is what I got from my interaction with the Indian students and the faculty. So this is not from me. So please do not consider that I'm criticizing. I'm only telling you, summarizing here what I heard, or if any of you is a decision maker, providing you a honest feedback, which I got from my Indian colleagues at different level. So what are the mitigation things? What we need to do? First of all, we realize our true self, who we are. And we need to know that we Indians are the best. We are not lacking anything anybody else in the world, right? If the opportunities are provided, if the atmosphere is created. And Mahatma Gandhi said that you be the change you want to see in the world. Each of us has to take that responsibility, right? And this is extremely important. Be assertive. Outside here in England or in US, people think that Indians do a lot of chamchagiri. They speak what boss wants to hear. They move more, So we really have to be honest, tell what it is, right? So, like for example, some people, 25 people wrote a letter to President of Congress Party, and those people are now the backbencher. So this is one problem. People are afraid to speak up, and this is the real example which happened like in a few weeks' time, right? The lack of ownership. So we need to take ownership. Explore local, national, international collaborations. Now with this COVID, it has created an environment. I'm talking to you. I don't have to travel all the way to Karnataka, right? And can talk to you, connect you. So you can invite anybody in the world today, right? To talk to you, to anybody. So we now have a global platform and free, zero cost, right? Find partners where you can do experimental work. And you can send the students anywhere in the world today. Everybody is looking for people. Now, one of the things which you can enjoy, visit expos. Each of us, I go, if I see any expo, when I go to India, where I stay in Delhi is my hometown, then there is Pragati Maidan in Delhi, and always there is an expo. So I always go to expo and see there what is happening in India, who are the players, what they are doing. Last time I visited an LED expo, and I learned a lot of what is happening there. So you go to expo, meet and talk to the industry, and find out what are their needs, how you can collaborate with them. Try to work on more than one project. Be your own boss and compete with yourself. Have a balance and work on both near-term, long-term projects. Think outside the box. Have industry development. So I'm sorry, shall we stop? Because I have 7 more slides. I have gone over time. I'm trying to give you whatever I know here. What do we do? I'll take another 10 minutes. Is that okay?
Yes, sir. Yes, sir.
Okay. Thank you. Thank you for your patience. So the thing today, the hardware, software, firmware, glueware, that's what students have always problem. What should they work on? So hardware continues to get better, smaller, lighter, and cheaper. And this is a challenge to India. The software is getting bigger, more complex, and expensive. And that's a big advantage and global opportunity for India. As I mentioned that at the product mature, 15% cost is hardware and 85% cost is software. So it's benefit to India. So what is moving towards software-defined reconfigurable system, whether it's network, is test measuring instrument, is radios, is your smartphone, they're all software-defined. And product often fails due to software. When you buy a phone which has better interfaces, like you want to buy, you will see that, oh, interfaces are bad. So the software really decides what works, what doesn't work. And the gluer make the system, of systems work. So the India is in a great position to benefit. I think the lack of awareness, right? We need to bring create a culture, right? So when we are training our students, we should try to help them, tell them, create a solid background of both hardware and software, both theoretical and experimental. Give them a big picture, end user and applications that I give you. If you are teaching, uncertainty principle, quantum wells, Raman effect, show them real applications. One of my famous, most favorite scientists is Richard Feynman. He used to say, if I can't explain to a high school kid, I have not understood it myself. So every time you are teaching something, just don't go and solve the differential equations or start mathematics. Try to spend some time. You can play YouTube video. On YouTube video, you can find something. Or if you go to Google Image, you can find some pictures or end product there. So include that and build prototype. You can get a lot of information today on YouTube, how to build. And ask your student to take courses on system engineering and product management, because if they join today, this has become a very critical skill, system engineering, how to manage a project. So if some of your students or some of you, because most of you are young, if you want to be an entrepreneur, that's what Government of India is emphasizing. So for that, you have to crack from inside. If you crack from inside, life comes out of it, right? Beautiful bird. But if somebody has to crack from outside, you are just somebody's food, right? Take the example, this benefit lesson from this egg. So Digital India has millions of programs and problems, and so are opportunities. And technology can address all of them. Invite business, industry, defense, and city leaders to learn about their needs and wants. Like you have invited me, I'm from industry. I'm sharing you, bigger picture. I'm not going deep into one particular technology, but similarly invite somebody from Bharathi Electronics, from ITI, from NAL, invite them, what you can do for them, right? Look out for what society needs, then try to invent it. Visit expos, find better ways of doing the existing things. Light bulb was invented, more than 100 years ago, but still every day there are multiple patents and things are improving, right? Do brainstorm sessions group and come out of ideas. So like we have this talk, maybe some of you sit together, figure it out, what you should do, which area you should focus on. I'll be happy to join you in case you need it. Select a leader on rotation basis, record minutes, prepare a quad chart with supporting documents. People don't have time today. So if you are going somebody for some funding, have just one slide and quad chart, what, why, when, who, show that. Develop concepts and prototypes as part of your classroom projects. Technology source, your own R&D or collaboration, CSIR, provide clarity when none exists and create energy. Need to work under resource constraint space. You can provide products and services to anywhere in the world today, right? Think about these companies, Amazon, Uber, Facebook, Netflix, Alibaba, B&B. Amazon doesn't manufacture anything, but they sell everything. You can buy anything. Uber doesn't own any car, but they provide taxi anywhere, anytime, anywhere, right? Facebook does not create any content, but YouTube, Facebook, people create content and get it, right? Netflix, they don't have, now they have, but they don't really own any studio or any theater, right? But people are watching their film everywhere, right? Alibaba doesn't manufacture anything. Bed and breakfast, right? They don't own any hotel. So what I'm trying to say that today there are different business model, but your students, people often ask, what should I do? This is the slide I always share. They select your career very carefully and change it if necessary, right? I was a classroom-based officer in Government of India, MIT, but I figured it out. I was looking industrial licensing and I find that, hey, what I'm doing here? I'm wasting my life. This is the only life I'm going to live. And my wife was a professor, but we decided that I want to do something. I enjoy technology. So I went on and applied for a Cornell scholarship and got out of that. And I resigned from there and working with the technology because I enjoy it. I like to create things, right? So enjoy what you do for living. Then you never have to work. And ask people to watch people around you. People have multiple roles. Find what roles appeals them. Ask where they want to be after 5 years and the personal values and circumstances. more we plan our career, better we can face the unplanned events. But these two things are important. The Karma Yoga in India is highly misunderstood. In Karma Yoga, people say that, oh, you have a right to do your work and not to the fruits. And that's all garbage. The Karma Yoga, my spiritual guru Swami Dayananda Saraswati used to say, we are the authors of our action, but the results are subject to the hidden law of nature, right? So we do the work because we need the results, but sometimes we don't have a control on them, right? You want to drinking a cup of tea, you may find that a fly has come in, landed in there, right? Or your brother-in-law has shown up, or your spouse has called you all of a sudden. So what I'm trying to say that we have to do our best. If we fail, we fail, because results are subject to, that's the Karma Yoga. But the famous Douglas Adams used to say, I rarely end up where I was intending to go, but often ended up somewhere that I needed to be. Many of us will tell us, I never thought I'll be in USA. I come from a village. We didn't have any paved road. We did not have any toilet, no electricity, no tap water. Our houses were made of mud. We had to go to a primary school. We had to sit on the floor on a jute carpet. So I never thought that I will even go to any city or town, So, but nature takes you, where you have to be. And sometimes your failure, you think it's a failure, is not your failure. It is your, because some better opportunities are waiting for you somewhere else, right? So this Amitabh Bachchan was, I heard him saying that his father used to say that if you get what you want, it's good. But if you don't get what you want, even better, because the first one is based on your desire. Second one is based on the God's desire. So in my life, if I look back and I find that many things I wanted very badly, I did not get them. And that's the best thing happened to me, because there were better things, down the line. Something that IEEE had started, and Photonics Society has created a big thing out of this, and we are creating a portal. We will be launching very soon, that mentorship. And we have called something micro-mentoring. And we need to advise ourselves as well as our students, find a mentor. And ask if you do not know. Our scriptures, Bhagavad Gita, for example, all Upanishads, they are Q&A. They are not something, we are supposed to be seekers, not believers. We ask questions, we get reply. So ask if you do not know. This is the culture we need to create, right? As I mentioned that we are born divine, but ignorant, but we need a teacher. And that's why teachers are very important. But mentorship, a mentor listens and gives advice and objective feedback with our interest at heart. Help us at the time of distress. Identify our internal strengths, weaknesses, opportunities, and threats. But if you have one in organization, your mentor tells you corporate cultures and valuable career moves, right? It's a two-stage process. We get advice, but mentor, get the chance to pass on the wisdom. And it's a reverse mentoring is very important. Today, I'm learning more from my kids, my grandkids. From yesterday, I was talking to a friend who is my classmate, who is a professor in Colorado. He said 25% of the things he learned from his students. The famous scientists, they will tell you they learn or they are where they are because of their postdocs or the people working under them. So we learn from others. It's called reverse mentoring. And every great achiever is inspired by a great mentor. When I talk about myself, I say my mentor did this, my mentor advised me this, and I give entire credit to my mentor, right? So mentors can change a donkey into a horse, right? And so reverse mentoring is also, I mentioned that, extremely important. So most of you might know that he's commander-in-chief, right, of Shri Ram's army, right? He could do anything, right? He can fly, he can bring mountain, and he can do anything. So from this picture, and by the way, I'm not teaching religion here, but there's a lot of information in this image. First of all, as you might know, that Hanumanji, he was a very sharati, a notorious child in his childhood, right, in boyhood. So he was cursed. Because he used to, get the tree out and throw in a rishi's havan or this thing. So he used to create a lot of problems. So he was cursed that he will not know his strength unless somebody reminds him. So he carried a curse. that he will not know his strength unless somebody reminds him. So Shubri or Angad or somebody has to say, hey, you can fly, you can do this, you can do that, right? That curse we all have. We do not know our strength. We do not know what to achieve. So we have to, our mentors, our parents, our friends, they help us to realize our strength, our hidden strength. We have a lot of hidden things, right? And we have a duty to inspire others to make them realize what are their strengths, right? So Hanumanji is Hanumanji, right? Because of other people. So he was, other people will tell him, and he will go an extra mile. He will not come with a problem. I didn't get there. Or like he went to, to Himalayas to get this herb, right? And he did not know. He brought the whole mountain. So we all need to be part of the solution and not the problem, right? We can't say that, when you talk to people, people talk about problem, but we really need to talk about solution. Go and get. And that's what some community in India, I'm sorry to say this, but like, for example, people in Punjab, people in Gujarat, people in Sindhis, Gujaratis, Marwadis, they have this culture, go and get it. In Punjab, if you go there, they have 3 diamonds. They focus on the results. They don't focus about other things. They ignore a lot of other things. They just focus on the real thing. Rajkumar ji could say that. They would say, "Ki farak panda ho?" Basha sab chalta hai, So they like to do things and they make things happen. So you need to learn something. So I mentioned that the lifetime employments are disappearing, and for that, we need to address that. We need to find a mentor, and we can use the IEEE resources if you need. If you're working, if you have a company, behave like an employee and more like an owner. Dedicate yourself to creating, selling, and delivering values. View your employer like a customer. So if you're working for a company, don't consider that they are my boss. Consider that they are a customer. What you do, you sell it to them. Invest heavily in your core skills and technology, and develop soft skills. Remember, refine your communication skill. Be self-managed, self-reliant. Work on winning projects. Develop teamwork skills. Right? This is what's lacking in India. Right? People say that that 4 Indians cannot work together until they are carrying a 5th one on their shoulders. That need to be changed. Be ready for disruption, digitization, Uberization, globalization, outsourcing, merger, acquisition, risk, and downsizing, right? So the truth, honesty, respect, they are priceless attributes of self. Well, we need to take a lesson from a tree, stand tall and proud, be content with your natural beauty, drink plenty of water, remember your roots, and that's what I'm doing. I don't forget my roots. Whatever I am is because of my Indian roots, Be useful to society by offering whatever you can. This is what I'm doing. Beautify your surrounding, enjoy your view and your true nature, plant trees and shrubs to purify air and beautify your surroundings. So to summary and recommendations, I believe that this 21st century belongs to photons, like 20th century belongs to electrons. Artificial intelligence, broadband access technologies will change the world, and they will lead the 4th industrial revolution. Photonics offers unprecedented opportunities and challenges. Read tutorials, articles, IEEE journals, magazines, newsletters, technology trends, and keep yourself up to date. Pursue every opportunity to gain first-hand practical experience. Attend conferences, trade shows, job fairs. Build network of friends and well-wishers. If you are in the wrong field, change it is never too late. Position yourself to build a successful, enjoyable career, in digital India, smart and skilled India. Don't hold to a familiar pain, consider trading it to unfamiliar pleasure, right? So that's all I have, Jai Hind, Jai Photon, and good luck. So we could have, comments, discussion, questions, whatever you want. I'm done with my talk. Thank you.
Thank you very much, sir. Thank you. Thank you very much, sir, for valuable information about the...
It has taken, I'm so sorry.
Valuable information about the advances in photonics will revolutionize healthcare and also provides the new ways of detecting, treating, and even preventing the illness also. And also about emerging technologies such as Internet of Things, artificial intelligence, learning, and cloud computing that are photonics, sir. Thank you very much, sir. And many of the participants have commented that the session was extremely useful and informative, sir. Thank you very much, sir. Sir, there are a couple of chat box window. We can take them quickly. Shall I?
Yeah, sure. I don't see chat box here. I have on chat box. I don't see any question here.
Yes, actually participants are watching your session in YouTube. This is the for the participants.
How many people we had, by the way?
Hello.
So right now, 65 participants are there, sir.
Okay, thank you.
So, shall I read the question, sir?
Yeah.
So first question is from Anita Menon, madam. What are the prerequisites for studying photonics? How can it be introduced as a UG course in electronics?
Actually, there is no prerequisite. Photonics is so, we are fortunate that we live with light, right? We need light, right? We know the LED bulb, we have the bulb, the lighting. So we know the light, my granddaughter is 3 years old and she go to KG and we have the STEM kit I took to the school and I did the experiments with little kids, with the reflection, scattering the color, using the 3 basic color, blue, red, green, mixing them, creating it. And these kids, they're little babies, right? 3 years, 4 years. They can put their hands on there, mix the color, can create any color, white color, blue color, red color. So there is no prerequisite, And my other granddaughter, 10 years old granddaughter, I actually did the same thing with her. I have 5 grandkids. So this granddaughter, they had a telescope and the comet, she took the comet photograph. She could see that. So there is no, the problem is the senior people. I'll give you an example here. It's not a joke. It's a real thing. In Bell Labs, we had a show for investors. So it so happened that the communication minister from India, his name is at the time Paswan, he said some Paswan, right? Communication minister. So he happened to USA. So he came to visit Bell Labs. And our director, our Kumar, Arun Natravali, Indian, and he came to this booth. So this guy was transmitting 100 wavelength, and he thought that to the minister he may not be technical, so he used the word that we are transmitting 100 colors. Now he made a mistake. The minister said there are only 7 colors. How can you transmit 100 colors? He tried to explain that, that these are 100 colors, but he felt that because he studied in school only 7 colors. So if you have to deal with some politicians, then you don't use the word, you have to use the right terminology, but there is really no prerequisite. Anybody can. I was from electronics and I changed to photonics at later part of my career. So there is no prerequisite. It's very simple. We all know the photons.
Yes, sir. Sir, next question is from Rohit, sir. Can we use optical fiber for high power transmission?
Can we use?
Optical fiber for high power transmission.
Yeah, optical power, high power. High power means electrical power, right?
Yes, sir.
So yeah, you can use optical, and actually people are working on this, but you have to use a large core fiber, right? You cannot use the single mode fiber, right? If you are transmitting the high power, so you have to use a large core fiber so that you can transmit. It will be a multi-mode signal, and you can transmit more power, because what happens that there are no linear effect. If the power density is too large, then there are other effects there. So yes, people are doing that or using optical fiber, transmit that, but then you need a high power detector on the other side. But of course, there's always a limit. Actually, people are also trying to transmit electric power through free space optical communication. Then you can send a large beam of the photons, right? Other side you can detect and you can convert into electricity. I mean, that's what we are doing in this photovoltaics, right? Getting the electricity from sun, right? So when you have the solar system, you are really transmitting the electricity from sun to wherever you are putting the solar cell, right? That is through the wireless, we are getting the electricity from sun.
Girijamba?
Yes, sir.
I would like to interrupt Naresh ji. Actually, in India, Dr. Balaji Srinivas from IIT Chennai, he is working on high voltage fibers. I think they can contact. Dr. Balaji Srinivas from IIT Chennai.
Okay, sir. Okay. Go to next question, sir, from the participant. Sir, is it possible to replace the entire silicon chips by photonic chip? From Madhukeshwara, sir.
If you say, repeat again question.
Yes, sir. Sure, definitely. Is it possible to replace the entire silicon chips by photonic chips?
So I had 2 slides on that. No, absolutely not.
Yeah.
That's what I said, that the electron is skinny, photon is very fat. In electronics, you can have billions of transistors in 1 millimeter by 1 millimeter, area. In photonics, you can't do that. Photonics is good for what it is good for. It is for, lasers and detectors and some other applications. So there is no way you can replace silicon IC with the photonic IC. There's no way, absolutely no way. And if you can make it, then it would be so expensive, that you can't afford it.
Yes, sir. Yes, sir. Right. Thank you, sir. We are lucky to have you speak about this interesting topic.
Hello, madam.
BBC,
Hello,
yes, sir.
madam, I have a question. I have a question to. Hello.
Naresh, sir.
Yes, sir.
Sir, in photonics, what about the manpower requirement and technicians for photonic applications? Is there any big demand for manpower for photonic applications in the near future?
Well, that's what my talk was all about, that all the applications I talked about, right? That's where you need the manpower, right? Everywhere, all my slides, right? They were about opportunities, right? I did not go into the technology part. I'm talking about opportunities. So everything I mentioned that if you want to make, like, for example, this Adani group, I think they got a big project for solar plant. They had to make the solar cells. They would be needing a lot of people. I showed that the LED guys, they want to make LED chips. They need a lot of people. So for every application, you need manpower. So manpower is needed everything, everywhere, right? And there's a shortage there. India does not have the manpower. So if you ask anybody today, you may find theoreticians, but we need to have technicians, we need to have engineers who can make things, and that's missing, And because of that, many industries are not setting up. They feel that there is no skilled manpower. So I mentioned that Prime Minister Modi mentioned that on 15th of August on Radford that they want to take fiber to every Gram Panchayat, he gave a date, So if you have fiber going there, you need to maintain that network. You need to create a lot of applications. You need to create new business model, new applications, right? It depends on your imaginations, the number of applications you can create. So each slide which I had was require manpower and had potential of generating, huge employment and contribution to GDP.
So, what is your suggestion regarding creation of such manpower, sir? What are the different ways are available for creation of such manpower?
So, first of all, is this Mr. Prasad? Dr. Prasad, could you first introduce me? Where are you and which organization you are in? Then we can talk more about it. It's very interesting.
I am Dr. S.M. Prasad. I work for Government of Karnataka in the Department of Technical Education, where we produce diploma holders for technician level jobs.
Right. So
now we are intending to revise our curriculum. We are intending to open some courses.
Right. So Shrikanji mentioned that about it. So in my presentation, see, you have to think about all my slides were really meant for where we need manpower, like smart cities, right? Smart cities is a real application, right? Government of India has already identified 99 smart cities and allocated funds.
Yes.
So these vocational schools, right, we need to have a test bed there so that people can see how does a smart city would look like. So if you go to China here, in China, I've been to so many times, so the companies there, they would have a whole floor, showing smart city how it look like. They would have all kind of building blocks in there, and that when people come from Middle East, from different part of the world, then they can imagine how the smart city would look like. So the first thing that you are saying is that to answer that, if these vocational schools, and these test beds do not cost much money, by the way, they are very inexpensive, maybe very, very inexpensive. It just require, and I could help there, So if you create a test bed and train your technicians there, then you will find that day before even they graduate, they will find jobs, because each town, each village, they want to convert their infrastructure to smart infrastructure, whether it is they are trying to put smart electric meter, they want to have smart lighting, they want to have everything smart. So the test bed for this is one area. Then we need to have a small clean room where people can manufacture, people can make some crude device like LED light, right? Or you can make the solar cell this way, because that's where India needs very badly, right? Every home needs several LED lamps, right? LED bulbs, right? And this solar system, India is going to have more and more and more solar system, everywhere. So the point I'm making is that there are applications are unlimited, and how do we go about it? We need to set up a test bed. So one is the communication test bed, one is the smart city test bed. And so some of these things which require very little investment, but the payoff is huge. We can have a meeting between Shrikantji, myself, you can discuss, more about it.
Yes, certainly, sir. We'll look forward for your active cooperation in this regard, sir, because we have
yeah, we need to involve industry, local industry also.
So we always look forward for your active cooperation in this regard, sir. Thank you very much.
I mean, if you invite, people from Bharathi.
Yeah,
Sorry.
Prasad ji.
Yeah.
Yeah, I think whatever you in an appropriate time you asked a very good question to Naresh Chand ji, and I think we will form some good diploma program. I think with that one, I think Girijamba, let us end it with hello.
Yeah, yes, sir.
Yeah, you please ask. Yeah.
Thank you.
Sir, on behalf of Vidyavardhaka College of Engineering and entire staff, I wholeheartedly thank you for providing wonderful insights about the emerging trends in photonics, sir. I'm sure that the participants must have benefited immensely by attending your session. Very grateful to you, sir. And I also thank all the participants for your patience listening. Thank you, everyone. Dear participants, the feedback and attendance link will be shared to you in respective email IDs and also in WhatsApp group. Kindly fill it. Thank you, everyone. Thank you very much, sir.
Thank you so much for inviting me and putting up with me for 3 hours. It's a long time. I hope for me it's a daytime, but for you it's nighttime, right? So I hope you had your dinner, and if you did not, then I wish you good appetite and good sleep and good dreams, and you can approach me for anything I could do for you people. Okay, thank you so much for inviting me.
Thank you very much, sir. Over to
Okay.
Shrikant.
Yeah. Hello. I think
Yes, sir.
some comments from Dr. Rajkumar. Dr. Rajkumar ji.
Yes. Good evening.
Yeah. Okay. I think you have some comments.
Are you able to hear me?
Yeah.
Yeah.
So I'm thankful to the organizers of this faculty development program for inviting me here and to share and to listen Dr. Naresh ji. Actually, Dr. Naresh ji shared very informative, inspiring, and about various applications of photonics technology in different areas, its challenges and opportunities. It is very rare talk, such talk we cannot expect every time. So I'm thankful to Naresh ji. Now, as I am from CSIO, Chandigarh, so CSIO has excellent facilities in the area of optical instrumentation and photonics. I think CSI is the only national laboratory which has such an excellent facility in the area of optics in civil sector. In defense, in DRDO and ISRO, we have some laboratories, but for civil applications, CSI is the only laboratories where we work in optical instrumentation and to fulfill various requirements from the defense, healthcare, scientific instruments, etc. One of the important technology we developed at CS is head-up display. I think most of you will be knowing about LCA Tejas. So head-up display for Tejas and also tested and is from there. That is commissioned. So in my group, actually I am working particularly in holographic and interferometric area. So my group developed various novel interferometers and recently developed a digital portable digital holographic camera that has lot of applications in non-vector testing applications, slurring systems, laser lithography, and holographic displays. As you know that optics and photonics technology are very important for the progress of any society, as these are required in any field, including new research, industry, healthcare, as Dr. Naresh told, various applications. Now, India has developed good facilities and expertise at research level. But India lacks industrial implementation, as Prakash also asked about that. And industrial implementation is the growth engine of any country. Presently, we are importing even smallest components, including lenses, prisms, grating, etc. And these are required in large number in the manufacture of classical equipments, scientific instruments, including Raman spectrometer we are importing. Interferometers, lasers, everything is being imported. So we should target our industry, that we should help them so that India can achieve greater heights in the area of this optics and photonics. And one possible way is by imparting quality education, we can do it. Presently, we have many good institutes which impart technical high quality education at higher level, like MTech or master's levels or some PhDs. But industry generally don't need that. They are at manager levels. Industry also needs personnel at grassroots level. So one of the reasons of not flourishing Indian optical industry is non-availability of trained manpower. And thus, we are unable to manufacture high quality products which generally we are importing. We should not only stop import, we should start export also. For that, sincere efforts should be required to impart quality education not only at higher level, but also at grassroots level, which is very important. And I thank Professor Shrikant for his sincere initiatives to spreading awareness about photonics technology in India. He is constantly organizing various workshops, seminars, and these faculty development programs. He is inviting people, best faculty from not only India but abroad also, like Naresh ji. So it's very important that we should go at grassroots level like ITI, diploma, and graduation. Few universities are offering an MTech, like Calcutta University, Cochin University, Science and Technology, Guru Jambeshwar University also started. But I think no one is offering diploma or ITI level education, technical education. And this is very important to handle, to run the machines. We are importing high cost machines, but these generally remains underutilized due to non-availability of trained manpower, which can maintain them, which can run them. So this is very important, and I think your efforts in this direction will be very fruitful. At last, I convey my best wishes to the organizers of this faculty development program on this important topic, and for inviting best available faculty, not only from India, but from abroad also. I hope the participants will gain useful information about these emerging technologies and will help in benefiting the society through further spreading the acquired knowledge. We have best faculty facilities, but are mentally slave. We still think that Westerns are doing good things, but we can also do it. Should overcome this inferiority. Fruitful work helps in development of confidence. So we should start some fruitful work. Some technical fruitful trainings are required for that. Over the years, CSIR also has changed a lot. Now it is more accessible to the general public, like through ACSR, Academy of Scientific and Innovative Research. So students are coming to our laboratories. They have access to good facilities. They are doing good research. We can also be collaborating with research projects. CSR also invite public for lab visits on various occasions. Some industry can also visit there. So doing all these things and to overcome all these things, there are hurdles at every step, but with grace and confidence. Confidence that the technical expertise and work ethics are very important to develop the confidence. This could be overcome. At the last, I thank you very much, and I convey my best wishes to all of you for this faculty development program. Thank you.
Thank you, Dr. Rajkumar. I think Dr. S.M. Prasad, your comments, please. I think Dr. Rajkumar is there. Dr. Prasad? Prasad ji.
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
You can have one or two questions with Dr. Rajkumar for framing your diploma in photonics.
Yes, sir. Actually, I had elaborate a session with Dr. Naresh Chandra and Dr. Rajkumar. So with your invitation, I joined this meeting. As you know, we are in the process of setting up new courses and setting up a revision of our curriculum. So in this respect, I wanted some inputs. In fact, I could get a lot of inputs from this session. And this photonics happens to be emerging technology, and it needs immense manpower in the near future. Probably to cater that technician level manpower, we may create one diploma course for photonics applications and photonics related skills, or we can have a specialization in the existing courses for photonics. So in this matter, I always expect your active cooperation, and I look forward for your cooperation in the future, sir.
Yes, Dr. Prasad, we will be available.
Yeah, I thank Dr. Srikanth for having given me this opportunity to join with you all, to associate with you all. Thank you, sir.
I think before ending this session, I really thank the organizers, especially the Vidyavardhaka College of Engineering, and also some experts like Dr. Naresh Chand, Dr. Rajkumar, and Dr. S.M. Prasad. They are very keen in developing photonics, especially Dr. Rajkumar has given to develop photonics in India. Dr. S.M. Prasad wanted to develop photonics in Karnataka. Dr. Naresh Chand, sitting from US, he want to develop photonics India. So this is where actually we need to work as a team. So we are doing it. Actually, I think Dr. Rajkumar may be knowing it. We are in the Prakash Bharathi group. We are very active, but unfortunately, we need to do some outcomes that is not happening. I think now this is the time that we should do some very good work, and we should develop the manpower for photonics. In that context, I think Dr. S.M. Prasad definitely he has got a good commissioner of technical education. I think Pradeep, IAS officer, and he is very much interested in developing this kind of curriculum. With his this one, we can go for a good diploma course, so that what solar and what nanotechnology and even sensors and optical networks they can put together. We can make one trial basis pilot project like that. As you said, Dr. Rajkumar, we have actually discussed in Varanasi, we remember in Janpur, regarding starting up of a diploma course. You remember, Dr. Rajkumar?
Yes, we don't
Yeah. And anyhow,
this platforms, including various meetings of Optical Society of India. I read that issue there also.
Yeah. So it is now the time that Dr. S.M. Prasad has come forward to open one new photonics diploma, and we hope that it will be materialized soon, and we will start the diploma from Government of Karnataka side. So
Yeah,
once
that
again,
is very good initiative.
I thank Naresh ji, Rajkumar ji, and SM Prasad. They are invitees. Anyhow, I am a host. I need not have to thank Giridamba. Is it okay, Giridamba?
Sir, Srikant sir.
Not to Giridamba, Professor Giridamba. Okay. Of course, she is my student. She was my student, and she will be my student. Okay.
Srikant sir.
Okay.
Hello, Srikant sir.
Yes, sir. Yes, sir.
So Prasadji, please, if you could send me your email, it would be wonderful, because I'm glad that I met you, because I had a lot of ideas and I did not know there was no taker. But first time in my last 8 months of effort, I met somebody where I see some hope. So far I have been meeting, the dead end, but you are the first person I met who could do something. Because most of the places, because Dr. Rajkumar ji say, the MTech or PhDs, what I have in my mind is, MTech, PhD do not really help, what India needs right now. We need to create, the diploma holder or technicians or test bed, because there you can't do PhD, but you can, create the manpower. So I really thank you for joining, and I would like to, work with you and help you, and maybe we could start from somewhere. There is always big journey start from a small step.
Yes, sir.
Thank you.
In that direction, I will create a platform to interact with our commissioner as well, and we will put up a proposal. I am very eager to take it forward, sir.
Yeah, and I will help you. By the way, accident facility, I could donate you something, or I could get you from somewhere. Oftentimes, one thing I must tell you that a lot of times in India, if we can get away of this, there are a lot of things today are available at throwaway price. If you want to buy some equipment or etc., either you used market or